my computer is getting old. We use laptops and I have used it. I have every software that got created. Okay. Good afternoon, guys. My name is Chad Kirby, and my full-time job, I teach for Dunwoody College of Technology, electrical design and electrical construction for the last 10 years. And let me get to this young fellows here. Here you go. That's what my friend there. So for the last 10 years I've been at Dunwoody, I'm the head of the electrical department here, and I teach electrical design, electrical construction. My background is I'm a registered electrical engineer in Minnesota, and I did work on multiple buildings, including Uganda buildings. Probably like you were familiar with Uganda buildings. So if there's any mistakes, and I know of one, it's my fault plus others. I take the responsibility for that. So my background, as I said, power engineer. I did medium voltage and low voltage and 600 voltage or less. I did the distribution for small utilities as well as 600 volt or less too. I'm also a master electrician in the state of Minnesota. So I like to futz around with things. I'm not as good as you are guys in the field. So, but I did mostly a lot of residential and commercial. Not high-profile commercial, small commercial buildings as an electrician. As an engineer, we did hospitals, sport arenas, data centers, you name it, and plus distribution system for utilities up to 69K. So that's kind of my background. I've been in the industry for 21 years. My LinkedIn profile is up and running. Chat here if anybody wants to link with me. And because I have nothing to do lately, I do have my YouTube channel, and I'm not young, as you can tell. But I jumped into the YouTube channel. I have, I know if I told you, some of you were in my class before. I have close to 700 hours of electrical code, 700 hours, 305 videos, grounding and bonding and you name it, everything, all code. You're not going to see Chad doing other things other than code. So really cool. If this works, and Dunwoody authorized me, might be a YouTube channel tonight. So, so that's kind of what I do. A couple of things I want to share with you guys. I'm covering for my colleague Jeff Kovic, so this is typically not my class, but I'm covering it. In the folder that you have in front of you, I do have the PowerPoint presentation in one side, and also 3 activities that we're going to do, and hopefully it will work better than the first team, because we didn't have enough time. We have 2 hands-on activities, and 1 activity that you guys have to specify the proper PPE. So that's what we're going to do in 4 hours. What I usually do with people is every 1 hour I give you 5 minutes break, so remind me so I don't put you to sleep. On the clock we'll give you 5 minutes. So to help me with this, I do have with me the latest and the greatest 70E. Before I start, how many of you guys are licensed electrician? Raise your hands just to see so I don't make mistakes here. Good. How many of you are engineers? We have engineers? Electrical engineers? Okay, so electrical engineers. So I'm going to be walking you guys for the most part with 70E. You're familiar with this document, a lot of you. So that's the latest and the greatest 70E. And also to help me, you can't do electrical work without having the Bible with you, right? So I have the National Electric Code here. And also, I know you guys, some of your distribution system from Uganda, and I know you guys have a 13A distribution system in the area here that you get, and I believe it or not, I still have one of your online diagrams here from Uganda days. This is not the latest and the greatest, just to grab this one as I was leaving. This is the National Electric Safety Code. If you work, and this has not a whole lot to do with this one. This is the medium voltage Bible, I call it. And this one's safety for all. So you probably, you'll hear the people talk about National Electric Safety Code. That's the medium voltage code. The safety code is the one that you're looking at here, the 70E. So I grab this one with me. For those of you who do medium voltage, if you don't do anything higher than 600 voltage, you can close your ears. I found this is very interesting book about switchyard and switch gears and switchboards, medium voltage, higher than 600 volt, up to, they go very high here, up to 1,000,000 volt here, but there's a lot of chapters here, really, really cool. How to put substation, 38 substation in a safe working condition. So if you don't work in anything higher than 600 volt, this doesn't do you any good. That's a really cool book to have as a reference. Okay, so that's all I have for you. OSHA, of course, we can't start anything about OSHA. OSHA, because you're probably familiar with this 29 CFR 1926 OSHA. There's one section here, tiny little section about electrical safety, mostly NEC code book requirement and 70E, mostly. I don't know if you know the correlation between these two, and again, I don't claim to be expert in safety, but for years, the NFPA wanted to be the standard for safety for OSHA. There's some politics involved in it. Though 70E is almost the industry adopted standard for safety without being safe in OSHA. So if you meet 70E, you exceeded what OSHA asked for the most part, and actually for all the parts, for OSHA said about electrical safety. There's other safeties, you know, fall and all this good stuff that you have to adhere to. So I thought grab these with me. Every time I find something really cool, I share it with my friends. I don't know if you guys have seen this. This is electrical professional reference DeWalt. You're familiar with DeWalt tools. The DeWalt tools. This one 10 times better than ugly, and I don't work for anyone of them, believe me. I'm not a salesman. So 2011, NEC Footbook 2011. Standard sizes of hot metal enclosures for pole boxes are right here. You can't find these in the tool. Standard sizes of disconnects. Where do you find standard sizes of disconnects? Heavy duty disconnect. You can't find them in the code, can you? They're not in the code. The overcompression device on the code. They're here. California, we're a way of three-way switching. How to switch three-way if you forgot how to do the California way, right here, among other things. Couple size, tons of things. That's really cool. The electrical calculator is always like to share with everybody. If you are in the design business and you need to design a disconnect, a fuse, and a feeder for 100 horsepower, 480, say a rooftop unit, or say let's just say a fan. A couple of clicks, you're here. Voltage drop calculation, you name it. To use this professionally, guys, you have to spend 4 hours. I timed myself 4 hours going through the manual to use it right. Otherwise, garbage in, garbage out. So you better use the code if you don't want to spend 4 hours looking at the manual. Okay, so that's what I have with me, and a couple of things to show you guys. So this class is about safety, and you guys have seen this before. A couple of things I want to mention: the relationship between the NEC code book and the electrical safety book. These two go hand in hand. And being an engineer, it you know, touched me a lot to say that safety starts with the design. If you do a crappy design on a building, the building will not be safe. So safety starts with designing the building. How do we design any building? And install it based on any sequence book. Decide how do we size speakers and branch circuits and switch gears, switch boards, and all the stuff. We size it based on any sequence book, right? We could start there. So safety start right here, and then when you design it safely, then you will operate these equipments and maintain it based on the safety. So safety starts with the code, NEC code book. So that's and in the NEC code book, you're going to find a lot of stuff, guys. This class is going to touch on basically two things: the hazard associated with using electrical power, and there are two major hazards that you guys are familiar with. Hazard number one is electrocution. Do not touch energized objects. Right? That's we all learned that. So that's hazard number one we'll talk about. The hazard number two is lately in the last 10 to 15 years becoming a big buzz. Is the arc flash, big ball of fire coming out of the switch gear up on the whole current happening inside ground fault or three-phase short circuit happening inside the switch gear. So because of this, because of the major hazard in any sequence book in the design, this is on the design stage, they want you to label, as you guys all know, you need to label your equipment with this word. It says, before you open this 4,000 amp switch here, be aware that there's something called arc flash hazard that could blow you up. Right? Isn't that what arc flash hazard is? That's the NEC code book requirement. And if you list, and if you summarize this one, guys, every electrical equipment that you open to troubleshoot or maintain need this label. All the panels, so the switch gears and switchboards, all the MCCs, motor control centers, all the control panels. You have a VFD with a disconnect, fuse disconnect, and so VFD that's driving a chiller. and people do maintenance on this VFD, right? You open that, you do troubleshooting, that requires a label on it. Control panel, that goes under control panel. So all these require labeling with the available arc fault for the equipment. The only thing that's excluding, and you guys don't do that, will it, right? You don't do residential wiring or troubleshooting, not at Mayo, no. So if a panel in your house and mine is not required, all other panels are required. Why do we have it? Because to work people who are qualified. Unqualified people shouldn't be there to start with. Well, this is for the qualified people. That be careful, big qualifiers on the chest if you open this panel. Right? Be aware of that. Any comments, guys, about this one? This is NEC code book, and that's start safety stuff with the design. So we designed it safely by putting this sticker here. 70E go further than that. I'll show you a couple of studies that I did for our college, arc flash studies. It specifies this one only require a warning. It doesn't tell you what the category is, what the prohibited boundaries on arc flash law. Doesn't say anything based on the NEC code book. This guy goes deeper into it. You'll see in a second. Okay, did I warn you that I have two speeds, one fast and one faster? So you guys have to slow me down if I go too fast or I get too excited about it. Then they have an information note. It tells you, by the way, you have to go with this to get more details about the arc flash. So severity of potential exposure, how to determine the touch and the planning of safe work practice, and the PPE selection, all this stuff. NEC code book refer you to 70E, which we're going to be covering in a second here. And then, so that's basically the whole arc flash. The second thing is they keep talking, guys, about qualified person like yourself, qualified person. OSHA talks about qualified person, NEC code book talk about qualified person, and 70E talk about qualified person. And they all have few things in common. Number one, a qualified person didn't mention anything about license. If you're a master official or a journeyman, that's one step towards being qualified. One step though. Qualified person, if you read through the whole definition, you have to have the knowledge and the skills. You got to school, you got some training, the knowledge and the skills about the construction and the operation of the electrical equipment. So you have a medium voltage switch here in a nuclear plant. You know how that medium voltage switch gear works in nuclear plant? I never worked there, so I don't have the knowledge. Knowledge and skills, operation and construction of the equipment, and have received safety training, like what we're doing and in the field. Safety training, how to recognize the electrical hazard and avoid it. Recognize and avoid the electrical hazard. So skills and knowledge and training to recognize and avoid the electrical hazard. If you never worked in a nuclear plant and they have electrical system here, I don't know how it acts. If there's an explosion-proof nuclear plant, how this will act. So I don't have the knowledge and skills, even though I'm a master professional electrical engineer. So it's unreal. We in Minnesota, because we like licensure, just because you're a master, people feel you can do everything. There's a story I can tell you about one of our designers. We did a project for Ellen Beckett. We did a project for State Farm Insurance Company in Bloomington, Illinois. So we sent one of our designers who happened to be a master official, walk into the switch here, and they were commissioning the building. And he was part of, he's not supposed to be commissioning, he was supposed to be representing the engineering firm. So long story short, there was a switch, and they were debating what does this switch do or not, and so single-handedly, he went and closed this switch. Now, you would never close a switch. We're not talking about a switch, 50 amp switch. These are 4,000 amp, 2,000 amp switches. So close the switch, close it on to see two sides of the utilities will be covered. Blow up half of the switch. So he's qualified, right? Master electrician. So you have to understand every system, guys. I'm telling this to the choir. You know your buildings. You know the building more than I do. You have to look at your building, one line diagram, risers, analyze how the building works before you start throwing switches left or right. Especially when it comes to high amp, high voltage systems. So that's a few things about the definition of qualified person. Recognize the hazard. And electrical safety. So that's basically the electrical safety training and recognize the hazard, person qualified. The second thing, you guys come to a training like this one. As a qualified people, you need to be able to recognize the PPE. We have a couple of exercises, PPE rated from 0 all the way to 4. And I heard that they go higher than 4, but it's not recognized. So how do you pick up the right PPE gear that you put on to work energized on equipment? We'll talk about this one. That an electrical training program should get you there. And safety work practice involved with specific equipment. How do you demonstrate safety work practice with electrical equipment? The same thing for the qualified people. You need to know the arc flash and the suit to use, insulated equipment and shields and test equipment and so forth. If you're a qualified person working on energized equipment, you need to know how to pick up your insulated tools, right? And the gear that you need to put on, right? And also how the system operates and testing equipment. I don't have a whole lot of testing. If you have a testing equipment, when you put the electrical equipment in the safe working conditions, there's steps. One of them is you have to test. The voltage does not exist after you disconnect. You have to know how to use and pick the right tools for the job, right? Voltage-wise, amp-wise, and so forth. So that's basically for electrical professionals, you have to know. Now, if you are working in the limited approach boundary, I have the back of the switchboard open, and I'm exposed to all these cover bar energized. That boundary is started with what we call it limited approach boundary. You move your hand here, you touch energized equipment. If you are to work on these, you need to know a few other things. So now only qualified person can get into this limited approach boundary. That's when I open the switch here and I'm working on it. A couple of things you need to know. You need to demonstrate the ability. You need to be able to tell which bus is energized just by understanding the construction. For example, industry standard, if you open the switch here, you're going to have three phase. What do you need to have? You have to have a horizontal switch, you're going to have horizontal bus. Vertical bus is coming out of it, right? And you're going to have, if you're going industry standard, if you go phase A, B, C, A, B, C, A, B, C, so these most likely are going to come, your ABC means energized, phase A, B, C, energized. You're going to have your grounded conductor, and you have your grounding conductor. So that's where you need to be able to distinguish which bar is going to be hot and which is not before you open this switch here. So, determine nominal voltage level of live parts. You would hope before you open the equipment, you know, is it 28.20, 28.277, 2.120, delta, open delta, I don't know if you guys use open delta, center tap delta, grounded corner delta, I don't know if you use any of these special equipment, or if you go higher voltage, 13A, which I know you do, you have to be able to distinguish what the voltage level of this equipment. The single most important one, guys, is this table, 130.4 CA and B. This will give you approach distance requirement. When you use this one, it will tell you if the voltage is this, 600 volt, then your limited approach, you're restricted and prohibited. You see a couple of things. These are big deal. Limited, prohibited, restricted, and limited. What are these values distance-wise from the energized object? Is it an inch, a foot, and the third one will be 4 feet or so forth. We're going to be using these two tables. And the most important thing, you work on energized object, what you need, PPE. You need to be able to pick up the right tools for the job. Safety tools, right? Do I need a shield? Don't I need a shield? What category shield and the equipment that you have? And so these are big deals if you're to work on the limited approach boundaries. Any comments, guys? Any questions? Any comments? Any questions? It's common sense when you're working with it. So these are the so when we do wear the appropriate PPE and based on the job hazard analysis, and there's two analyses. I don't think you guys maybe unless you're in the design or there's two hazards you have to do with your system. Hazard analysis. This will tell you the boundaries, meaning how far you can be from an energized object before you can, how far you can be before it's really dangerous for electrocution. We have three boundaries, we'll talk about them. The second analysis is, which is the worst, arc flash analysis. If you're standing doing nothing in the front of an open switch gear exposed to energized objects, and accidentally you drop something inside the switch gear, or this switch gear, there's a ground fault, and the circuit breaker try to interrupt the ground fault and explode. What's going to happen to you? How much arc is going to come out of it, and what's the blast?
So that's what they call it, hazard analysis and arc analysis. You'll see in a few seconds here. Okay, so that's a couple of things about what you get the training. Employee need to demonstrate, the employees demonstrate that they can select the proper test equipment, perform the voltage testing, understand the limitation of voltage. So if you are working, this is all for 70E. If you're working on equipment, guys, can I use this one on 13A system? You hope not. You know what I mean? A lot of us guys work on 600 volt or less, so we are guaranteed, you know, these meters are rated for 600 or 1,000 volt, and then you go higher than that, we get stuck. Can I use this one on a DC system? You guys have photovoltaic. Can I use this meter to measure DC? No. So that's knowing the equipment, how to measure it, and what the capability of your tools are. So that's a big understanding the limitation of voltage testing equipment. So that's as an employee. As an employer, you guys will do a quick quiz that we go over, and this will have to be put on file for you to prove to the authority having jurisdiction that you guys have gotten some type of a safety training. So training records, and this is all from 70E. That's why you guys came today to this class to get that training. So the training records, the topic of, so you need the training topic. What did we cover today? You can see the safety training 70E. Employee name, dates of training. You're going to sign a sheet today with your name and the date and all this good stuff. Date of training, content of the training, and it has to be kept during the employment of your employment at this place, and skills verified annually. And every year you have to verify that the skills, people are retaining these skills. So that's a couple of things about training to get for employees and employers, electrical safety training. Later on, I'm going to show you a flash with you guys an electrical safety training program that you have to have, or electrical safety program to work on the equipment. Now for the employers, for your employers, shall determine through, so this is your employee, as you can see, you have to be able to work on equipment and pick your PPE and wear it, and know the limitation of your tools. Or your employer, they have to supervise you, determined through regular supervision, through inspection, conducted at least annually, that each employee is complying with the safe related work practice required by the standard. That's coming in 2012, they made it very clear, 12. So they have to annual, I don't know how they do annual inspection, make sure that you are following the safety rules, meaning if you're working on an equipment, Energized, you have to put your PPE. Lockout, tagout procedures. Are you following the procedures for locking and tagging a piece of equipment from A to Z? And when you re-energize this equipment after you finish the work on it, now you're going to remove your lock or your tag, and you do the reverse function of the process. Are you following it properly? So all these have to be verified by your supervisor for the safety training. And unqualified person. I always like to mention in Minnesota, you're not supposed to work on any electrical equipment unless you're licensed by the state, right? As a master electrician, journeyman, or if you're doing maintenance, or unless you're under the direct supervision of a master electrician, or a journeyman electrician, or a maintenance electrician, right? That's our rule for the state of Minnesota. So unqualified person, that's going to be that doesn't mean they don't have a license. That means most likely they could have a license, but they're not qualified to work on this piece of equipment. It has nothing to do with a license, really. Hopefully, if you have a license, you have the qualification, but there's no correlation. So here's how they define it: have not received formal documented training in hazard of shock, injury due to electrical shock or electrical hazard, electric shock or other electrical hazard, electrical shock and blast. So that's basically what you are as an unqualified. Who cares? If I'm working on equipment and you're not qualified, you're not supposed to enter the limited approach without being escorted. A janitor walk into the switchgear room and your work opening a switchgear and grab PPE and you work on it, it's supposed to kick them out. Right? They can't enter the limited approach. They can enter escorted. You have somebody else escorting. Prohibited and restricted approach, no. You're going to see all these approaches. That's why they put the word unqualified person. You can be non-licensed and qualified to work under the jurisdiction of a license. So the licensed electrician and an apprentice, and you're opening and work on a switch your hub, and you have received training. You know how, as a non-licensed, you know how the system works, and you have received safety training, and you know what the hazard, the shock hazard, as well as the arc flash hazard is. You are qualified. Because then the correlation, license does not mean qualified and vice versa. Qualified does not mean licensed. Okay, so those guys shall not touch anything lower than over 50 volt. Over 50 volt to ground, they're not qualified. They don't know the hazard. So they're not qualified. Any comments, guys, before we go into training retraining? So you have to have the training. Just to summarize, to be qualified, you have to have the knowledge, the skills, operation and construction of the equipment. We seek safety training to recognize and avoid the hazard. The hazard could be shock hazard or arc flash hazard. You get this one, you're qualified. According to 70E. Now, according to Minnesota, if you're working by yourself, you have to be a trainer or a master or maintenance electrician, right? Maintenance only if you're doing maintenance. If you're not any of the above, you have to have a master or a journeyman or maintenance sitting right next to you at all times as you're performing your work. And that's a little bit abused sometimes. Now retraining. So we got your training, retraining. You see an employee not following the safety standards. You know, you're a supervisor and they're not following. What do you do to them? Instead of firing them, I hope you give them the option of the benefit of the doubt. Say, we're going to send you to be retrained again. Number two, new technologies. You have a UPS system coming, and you guys will know 750 kVA UPS will be installed. You haven't done it before. That requires some training of recognizing what is the hazard involved in installing a UPS system, right? That's required training. Safety practice, we're not in the normal scope of work. Bunch of you guys have never worked on energized equipment because you do the right thing, which is always, everybody knows what the rule is. The rule is everything they energize. The rule when you work on electrical equipment is the energize. That's rule number one. The exception is to work on equipment energized. So I know you're a hospital, so you probably upside down. You have the exception is working on energized, and the rule is working on energized. There's exception when you can work energized. You guys are one of these exceptions. But electrically speaking, the rule is de-energize, lockout, tagout, put the equipment in a safe working condition, and then work. Okay, so now, if you are not doing this on a daily basis, you might have forgotten how to work on energized equipment and need some training. And if you do a task less than once a year, you forgot. You know how to troubleshoot 660 volt DC systems. You don't do it that often. You might have require some training, retraining on the safety regarding to it. And if all they'll break loose every 3 years for all of them. Just to remind you, I'm sure you guys, the electricians especially, you probably have been in the class as well. Every 3 years they get refreshing your mind. So all this is the requirement from 70E. Who enforces 70E? Usually OSHA, and usually your safety. Every company has a safety director, safety manager. And you know why we enforce that? Because of lawsuits. You know, if you don't do all these programs, and God forbid you have an accident, you kill some electricians, and OSHA audits you, and where is your safety program? Safety training program. How often did you train the boat? The last time we got a training 10 years ago. So these are all because nobody wants to be liable for many reasons for killing an apprentice or an electrician. Any comments, guys, about training and retraining? That's why you are listening to your friend Chad instead of being somewhere else doing other nicer things. Okay, so this is just a couple of things, guys, about qualified person. Back into, I can't emphasize, electrical, so has documented training, avoiding the electrical hazard of working on or near exposed electrical equipment. That's from 70E. NEC code book almost say the same thing, except they add, actually they synchronized them in 2012 too. So skills, knowledge, number one, and safety training. You need to know the safety. You have received safety training and how to recognize and avoid the hazard to be a qualified person. Okay, any comments, guys? Any questions? Am I going too fast? Too slow? Right speed? Push you to right speed? Good. Busman. Are you guys fuse guys or circuit breaker guys? Okay.
Yeah.
Fuse?
Yeah. Both.
Or both? Okay. That war between fuse and circuit breaker, if you want to enjoy it, go to Busman website. They bombard you, anybody have been there? With everything, they make you, every time I watch them, I like circuit breaker because you can control them a lot, especially for medium voltage draw, not medium voltage, low voltage, 600 volt, power circuit breaker draw. I'm sure you guys have a draw switch here. They're really easy to parallel generators with them and maintenance of them and all this good stuff. You can't do that thing with fuses. But then when it comes to arc mass, fuses to my surprise, they're superior. They are superior on limiting the amount of arc dash that comes out of the equipment. So from a safety point of view, as an electrician, you probably would like to see a fused switch gear versus a circuit breaker switch gear. If it's sized right, back to the NEC book, it's sized right from the beginning. Is it safe? So if it's sized right from a safety point of view, I dare to say, if you have a fuse, currently fuses, and fast acting fuses, it will limit the amount of energy. So your chances of surviving an arc flash is a little bit higher. But there's disadvantage of them, of course. Okay, you can't coordinate them. Well, you can't coordinate them good, but you can't control them. You can't have single phasing on certain equipment. Have a solution for it. And of course, you have to change them every time. That might be inconvenience for some people. Versus a circuit breaker, you can reset that one if it's a ground fault low limit. If it's a high voltage, you know that you have to retest your circuit breaker if it gets a three-phase voltage circuit breaker because it alters the plane of the circuit breaker. That's realistic. If you have a three-phase short circuit on a circuit breaker, that circuit breaker characteristics no more. It could be all over. It needs to be recalibrated, retested. But that's only if you have a three-phase voltage circuit breaker. How often you get that? You guys get a lot of three-phase voltage circuit breaker. Somebody take phase A, phase B, phase C with a big cover bar, bolt them together and flip the switch on. That's the worst of the worst. Not often. I read an article one time, one of these magazines. It claims that 80% of faults in the electrical system are ground faults. 80% of them, phase to ground. 80% of what you see. You rarely see phase to phase, and you rarely see phase to phase to phase. Only a mistake done by somebody that you get phase to phase to phase. You go to Busman, guys. They have a little handbook for network safety. I have it downloaded. You can download it. This is an older version of it. It's really nice. I like it because you go through a lot of things. It sizes fuses, coordination of fuses, and it walks you through the safest fuse that you can put to limit the energy. Fast acting fuses so you can limit the arc flash, basically. I have a video I'll show you later how they use a circuit breaker rated right and a fuse rated right. The circuit breaker will explode violently while the fuse you can't even see that the fuse thread or open. But some of it is a propaganda tool, so I don't know. So that's a really good resource to have. Okay, so this is I think this is the most important thing that you guys probably, I don't know how much you agree with that one. Based on 70E, the rule is to work on things de-energized. That's the rule. The exception is to work on energized states, on the electrical energized. Everybody got that one? Rule is de-energized. Changing a balance on that baby here. Chad will jump in right now, disconnect it and change it, right? The rule is you have to disconnect the circuit, turn it off, and then change it. In 2008, because we got sick of maintenance electrician or even janitors walking in there and changing the balance and getting zapped by 277. So you guys remember what that 2008 came up with? The disconnect. And the industry came up with a load interrupter plug. Then you push it, you unplug the fixture, now it's dead, change the balance, or clean the fixture, especially for that one. But if you are to work on it energized, believe it or not, you have to follow the energized rules of working. You're going to see you would have based on if you will change the balance on that one, hot, you would have to have an energized work permit to work on it, signed by all your managers, programming, and all this good properly. You have to do that one. So what do most of us do? We energize it and work on it. And now with that little disconnect, you're laughing, you don't do that, you just jump in and change it. Fill the paperwork. Nobody's here, just change it. Here's where you can work on thing energized. Look at the unless, the exception is. Rule is the energized. Exception, number one, the employer demonstrate the following. The one who's going to send you to work, your employer have to demonstrate. Number one, de-energizing introduces increased hazard. You guys in the hospital. At 100 amp switchboard, I can't just disconnect it so I can install a circuit breaker in it because it kills the power in the whole hospital. Are you kidding me, Chad? So that's a good example where it increases more hazard, right? You're a hospital, you can't just shut down equipment. So that's number one. Number two, infeasible due to the equipment design and operation. Troubleshooting a VFD. How can you troubleshoot a VFD without energizing it? You need to see the signal coming in and out. I need to measure what's wrong with it. So a lot of us, you guys are maintenance electricians, you deal with it day in, day out. There's no power coming to the air handling unit. Okay, now what's happening? Is the disconnect engaged? Is the circuit breaker open? Is the fuse burned? So how are you going to do that if you don't have power? So so you have to do troubleshooting, then you have to work on the energize. So first, safety. Second, increase a lot of hazard if you don't de-energize. And the second one is you have to do that so you can troubleshoot the problem. And the last one is if you're working on 50 volt or less weaker units. There's not enough juice, there's not enough arc to actually go in. Any comments, guys, about these? And these are coming from Ocean70E, these articles. Rule de-energize. In your case, probably you guys work on a lot of things energized because of the, the type of business that you're in. We'll get into how to work on equipment energized and the permits and all the stuff in a second. So, am I repeating a lot of stuff that you guys know? It's good, for sure, for some of you, probably. Okay, so everybody knows that the rule, de-energize. How do you de-energize and what do you de-energize when you work on equipment? So we're going to start with de-energizing equipment to work on it. So de-energizing the equipment, energy control. A lot of us guys only care about de-energizing the electrical equipment, disconnecting the switch, now the equipment is safe to work on. And we keep forgetting that most of our equipment have other function, mechanical or thermal or pneumatic or hydraulic action that they're doing. And if you don't lock and tag the other sources of power, your fingers could disappear on you because of some hydraulic effect that happened inside that machine while you're troubleshooting it. Would that happen if you don't understand how the system works and you don't tag it? So long story short, when you energy control, you have to. We know how to do the electrical disconnect all sources of power to the equipment, electrical power, lock it and tag it and verify the lock and the tag and all stuff. Now, electrically speaking, it's skilled. It's safe. We all know that. Now, what we don't know, or some of us don't know, is we have to verify that none of these other energy sources exist. Right? You guys do that? Absolutely. Pneumatic, hydraulic, mechanical, chemical, steam, gas, water, residual thermal, gravity. I'm sure we have a lot of machines that does some or all of the above. We have to lock them at all, so it doesn't cut your fingers or burn your face from some type of steam that's coming out of this equipment. I would say 90% of I dare to say 90% of our equipment usually lock out that out here. The rest probably make 10, maybe 20% of locking the other sources of power. So pay attention to the other sources of power, not just electrical. Photovoltaic system, big deal now, right? You guys are installing a photovoltaic, or you have a photovoltaic system, you have wind, you try to be green, like the rest of the country, trying. So if you have multiple sources for the piece of equipment by code, if the equipment has multiple sources to disconnect the equipment, it has to be on the label. That's electrical code, that's a design part, back to design safe. You put all these. So a label like this caution, there's multiple sources of power coming to de-energize this equipment, and it lists all the sources of electrical power that's coming to this equipment, and you're supposed to go safely de-energize the equipment from all the sources, disconnect them, unlock them, verify that there is no voltage, and work on the equipment. All the sources of the power. Any comments guys about having the label for all the sources of power from the NDC code book, and you're supposed to disconnect all the sources of power? Comments, questions? Are you guys a quiet group or am I too loud here? No? Good? Okay. This is what scares me. VFD. Now I know control shops guys, people who make controls, they're doing it much better where they can separate the high voltage section from the low voltage section. Everything is becoming network these days. You can plug into your VFD, I'm sure you guys have it, and you get tons of info. So what we, unless you're doing the control, what we electricians do is really, it's like having a big horse with no soul in it, or no spirit. That's what a VFD is. If you have a chiller, I always say, a chiller, you have a big horse that doesn't have a soul. A soul would be all these computer things that you put in the VFD so you can control this piece of equipment. Now I don't know how many of you guys do that, but this is becoming a specialty. People who can do this stuff. And a lot of people have nothing to do with electrical. They're not electricians. But they're very specialized, very smart group of people to run these equipment, that train these equipment. So they open a panel like this one, and they're working with some type of a controller here, and look what you have here. You have three phases. If you have an arc flash between any of these terminals, what's going to happen? Arc flash, you're going to kill that technician that's going to work on a control pump. A lot of shops, they have been separated, where you can most of the time open, but if you're troubleshooting a VFD, you almost have to look at the whole big picture. So long story short, if you are anybody who's working on this piece of equipment where there is power, you have to have an Energized, you have to have the proper PPE, regardless of you being an electrician or a control technician or whatever you are in these equipment. Any comments, guys, from your experience with this? Any comments, any questions? MCCs, they have been separated. If you have MCCs, they have a low voltage section one side, a high voltage section. So sometimes, as long as they're separated, you don't have to worry about that. But if they're not separated, which some panel or not, you have to pay attention to this. You guys remember the rule of working on things? You're supposed to work on things de-energized, right? So only working on things de-energized, unless de-energizing the equipment increase the hazard. OSHA defined what is increase the hazard is. So because we don't know that. So in one of these sections, they introduce it as following. Interruption of life support. That's hospital. A lot of critical operating system and life safety systems that you guys have. Essential systems, critical life safety, equipment system and so forth. That you can work on the Energized. Deactivation of emergency alarm, shutdown hazardous location, ventilation system, total removal or illumination from the area. That's what NEC could came up with that little plug to eliminate the chances of people using this as an excuse to work on things Energized. So these are a few things that could get you to work on things Energized. So if such live parts cannot be de-energized, employee will have other protective devices to prevent direct contact with the light. So these are where you can go work live, and then when you work live, we're going to walk you through the two major hazards when you work live. The touch, the electrocution, and the arc flash. Okay, you guys have done lockout, tagout procedures, right? Everybody has done it. There are two types of lockout, tagout procedures. Anybody remember that? The two types? The simple lockout, tagout procedures. Anybody remember a simple lockout, tagout procedure and a complex lockout, tagout procedures? Anybody have that? These are not my words. These are 70E. So most of you are involved in the simple lockout, tagout procedures. And 70E here at the end, I'll show you in a second. They summarize a really nice process of conducting lockout, tagout. I summarized it right in here. So when you do lockout, tagout procedures, this is typical for the simple one. The first thing you need to do is demonstrate all sources of electrical supply to the equipment. You have to determine all the disconnect, all the power coming to the equipment, right? So we can disconnect it. So we know, how do you determine that? Just by looking, if you don't know the equipment, well, you guys live with the equipment, you know that. But if you don't, you have to look at the one-line diagram of risers. Are these familiar to you guys? Risers, one-line diagrams? To look at them. So we're going to determine all sources of electrical power to the equipment, safely interrupt the load current, then open positive disconnect devices. So do you disconnect the equipment just by turning the disconnect off? Is it the proper way of de-energizing a load? You have a chiller. How do you de-energize a chiller to working? You go to the disconnect and you shut it down first and you start working on it. What's the proper way of de-energizing a chiller? With what? I know controls. Yes, thank you. With the building automation system, you're supposed to, with your building automation system, I'm sure it's already interconnected. First you shut it down. So slow it down properly, bring it to a complete halt, then you disconnect and work. So that's what the proper way of interrupt the load the proper way. And then open positive disconnect switch. That's your disconnect. That you positively now, the three phases are completely isolated. That means the equipment is isolated. So we determine the sources, we disconnect the load, and we de-energize the load and disconnect it, de-energize, disconnect, and if possible, verify positive disconnect occurs. Anybody, you guys have medium voltage, interrupters. If you have a medium voltage, you have a tiny little window, especially the medium voltage, where fuse disconnect, where you can, after you de-energize the equipment, and you open the switch, you can actually look and you see these knives are open, very clear, they're not touching. So that's positive identification. I'm not sure if they do them in the low voltage. Positive identification without opening the panels. I guess after you open the panel, you will verify that they're positively, they're not engaged with disconnects. Because of malfunction, equipment guys malfunction all the time. Just because you move that handle doesn't mean the actual mechanical action happened for every phase, 1, 2, and 3, as we all know. So you have to verify that they're open. Now we verified either by looking through the door or when we open the panels. Up to this point, you're treating it as energized when you open the disconnect. And then you're going to apply your lockout or tagout device on it. And you guys are very familiar with the device, something like similar to this, and you would have your tag on it. Do you use tags or locks?
Yeah.
Cool. Okay, so you can use either tags or locks, and there's procedures to use a lock. The lock has to have some information about who put the lock on it. If you use a tag, all the information will be on that tag. The safest, obviously, is to use a lock. You can put the tag here and put the tag with, attach it to this piece of equipment. Hopefully, nobody can cut that little deal that you put it in here. So you lock it, or you tag it, or both. So we know how to do that. Now, is it energized up to this point yet? No, right? It's not energized based on OSHA. You lock it, you tag, and you verify. What do you need to do to make sure it's dead? You need to test for voltage on all known test points. You're going to go to the line, the load side of a disconnect, measure the voltage face to face, and you should get big fat 0. If you get big fat 0 between them, and I always like to go face to ground too, because if they're all sitting on the same phase, you still could have a malfunction, one where the 3 phases are tied together in one phase. So you face to ground 0, 0, 0, 0, face to face 0, 0, 0, done. Now, and before you use your meter, look how interesting that is. Before you have to verify that your meter is actually working. How many of us have grabbed a meter that doesn't work? So before you even test with the meter, you have to plug it into a known outlet like this, measure up, it's giving some juice so it's working. And after you test, you're supposed to also, after you test the equipment and verify that there is no voltage, you have to go to a known outlet and plug it in and say, yep, my meter still working. Because equipment malfunction. It might doesn't make sense because when you're working on a 20 amp grand circuit, but if you're working on a 4,000 amp switch here, or a 600 amp feeder, 480, I will do all of the above, if not more, if my life depends on it. You want to make sure that this piece of equipment is dead and there's nothing is going to energize it. So test the equipment and verify. The last thing, we don't do it in a low voltage enough because typically we don't do the last step in low voltage, we do it medium voltage. Ground the phases. Ground, anybody have ever ground the phases? Ground the phases. What you do is you take not a 4-aught conductor and you tie the phase A to B to C to the ground. That's not approved. You have to have an engineered bonding jumper approved for the interrupting rating, the relay, or the circuit breaker interrupting rating. And the amount of time that the circuit breaker will interrupt, typically 30 milliseconds, so 30 cycles, half a second. So this engineered bonding jumper clamp on phase A and goes to phase B, to phase C, and the last thing it goes down to the ground. They use it a lot. It's required in higher than 600 volt. It's not required on low voltage. Very few people do it in low voltage, if anything, but medium voltage all the time. So that's why when you hear, if you're energized, if you have a generator and you plug it into your house and you won't disconnect, and you lost power, say you lost power, you plug an outlet, as you shouldn't do that. Plug that out, you install your generator, plug into one outlet, now you have some juice in the house, and you did not disconnect yourself from the grid. What do? You're feeding power back into the grid. And they always tell us, oh, that we kill linemen people there. You really don't kill the linemen, because before you work in the line, that's what they typically do. But especially the linemen work, they bond them to the ground. Because if there's a crazy person who did not disconnect his generator from the grid, it will take this energy down to the ground instead of pumping it into somebody's heart. Okay, so other than number 6, you guys will do all these in one way or another. This is the lockout procedures. In the end of the book, guys, they have a really nice lockout tagout procedures that I told the group before, you guys, I think you should have these. These are $47. Is it expensive, $47? And they don't work for the people who sell them, right? Really nice to have a couple of these books to look at them. And Annex G has a lockout tagout procedures. It's summarized here, but the complex one. That's what I wanted. There's a complex, there is 2 ones. There is a simple lockout tagout procedures. That's what you saw. The complex one. When do you need to have something called complex lockout tagout procedure? A complex lockout tagout procedures require somebody in charge of all the locks and the tags. Basically safety coordinator on the site. Here's when you need them. Number 1, if you have multiple energy sources, or more than one source, you have to have something called one source of energy, not electrical energy, electrical and gas and thermal. You have to have a safety director in charge of the whole lockout tagout procedure. Multiple crews work with equipment. Multiple credits, different credits. Multiple locations, multiple employers, different employers. Unique disconnect means. And complex or particular switching schemes. If you have any of these, or if the lockout tagout goes through multiple shifts, right? You're locking it for a couple of days and shift after shift don't work on it, or new shift coming to work. You're required to do a complex. The complex require a safety director. Take all the keys of the locks and put them in one location in a box, unlock them. And that person will be in charge of the safety of all the employees on site, from all the contractors. So that's what the complex one, and so that's basically when you require it. And there's a couple of things that you need to do. In terms of lockout tagout procedures, guys, you need to have a procedures for lockout tagout like we did. You're supposed to review the procedures once a year. Procedure of locking and tagging out, and you're supposed to do the lockout tagout training, recognition of lockout tagout devices. Do you know that this is a lockout tagout device? You know, people come all the time, new employees coming. Installation of lockout devices, how to actually physically mechanically install them. Duty of employer in writing the procedures. Duty of employee in executing the procedures. So they have a whole list here of things that you need to do to verify lockout tagout procedures. It's really good to know. But the procedure itself is summarized in these six parts. So one of these is safe use of voltage detecting instruments. Maybe if you have an apprentice that doesn't know how to measure in DC and go measure in AC and get different voltages or no voltage, so you might have to verify the use of for trying to measure a current DC on this meter and not hitting anything, thinking it's dead. So a few things that you have to do in the complex procedures. Any questions about lockout tagout comments? Okay, so that's worth looking into. Okay, applying the lockout tagout procedure responsibility. Each person may be involved with equipment directly or indirectly shall use appropriate lockout tagout procedures. Anybody that can be affected by, when you do lockout tagout procedures, the people involved in working with equipment have to have their own lockout tagout, and also the people affected by it. You have to inform the people that in the building that there will not be chilled air today because we're working on the chill, or there will be no light over here because they will be indirectly affected, just the employees. The directly affected ones, they're working on the equipment, the mechanical guys have to lock it themselves. All persons involved shall be trained in their responsibility in executing the procedures. If you have a mechanical contractor working with the equipment, they also have to lock the equipment with theirs and be trained how to do the lockout tagout. This is my favorite. When you do lockout tagout, guys, things change over the years. We designed another building tour, I want to back it for you, but I'm sure you have added a few things since the design that happened. So that's where, when you add things, you need to put the most updated online diagram or riser. We can't just depend on what the old one-line diagram. Verify actual points and look at the latest and the greatest riser or plans in the building. And also you have to coordinate lockout tagout procedures with all personnel for the conformance. So these are all, anybody who's involved have to be trained how to lockout tagout, and people who are indirectly affected have to be informed that the equipment will be put in a lockout tagout procedures. You're not going to have light or you're not going to have air in the building. Any comments, guys? Any questions? In 2011, code 2011, it requires all medium voltage equipment to have a riser on inside it. Now this is engineering practice anyway. It has to be engineering practice. When you have a medium voltage or low voltage, you have to have a riser right in the room, the electrical room, where people can look at it and see how the equipment are tied together. 2011, it's a code requirement for design of medium voltage. You have a medium voltage system. Typically, you have to have two sources though. Like you have a switch here, one feed 13 in and another feed from the other side. So one feed in, and you have to have another feed out though. Because they want to exclude substations. We bring 13, you guys have done a lot of substations. You bring 13 in to the 13th floor, and then from there you have 208, 120 switch here, and 480, 270 switch here. That's not required because one section is medium voltage. But if you have a medium voltage switch, which you guys have in the basement, 13 and multiple 13 probably going out of it, you have like code down to have a riser right on the base of the switch here or on the wall. It's engineering standards, nothing new for the medium voltage. For low voltage, still engineering standard. If you have a project, you will have a riser on the face of the switch here or right on the side of the switch here in the room. Anybody think that this selective switch auto hand off could be used as a disconnect means for the equipment? No, you have to have the proper disconnect means. Usually a disconnect means like this one or a circuit breaker where you can lock it and tag it. So control equipment not approved lockout to go use one of these selective control buttons as you lock out tagout procedures. Okay, this is a good place where we can break for a quick 5 minutes. Okay? Keep you awake a little bit for the first hour. We'll see about the second hour.
On the very top of the penthouse is volunteers. All the male volunteers have their office up on the penthouse.
So how is London working for you?
Good.
Is it working good? Yeah. I heard, I can't do it. I thought you guys for some time they had one ground fault here. Ground fault for 1200 amp.
Yeah.
1200 amp.
That was exciting.
Was it what?
It was an exciting amp.
Exciting amp.
Yeah.
When was involved in that one? For you? So what was the issue? Ground fault in a 277?
No,
Yeah.
there was a. You gotta remember that I'm a low voltage guy, and the Franklin guys take care of all the needs at Franklin. So I heard the medium side setting. What I heard was there was a ground fault in their DC control circuitry.
Okay.
There was a UPS, pretty good sized DC control circuitry for all medium voltage switches. That faulted and killed the control circuit, and when that went, it took out one of their medium voltage switches.
When you say medium voltage,
13.
13A?
Yes.
On a ground fault?
Somehow, some way, that when that circuit, when that control circuit failed, we lost one feeder, one 13A feeder.
Oh, that's not good.
Or they were in the same room and there was water. I don't know how it went, but they lost the control
On the 13A.
the DC control circuit and a 13A feeder in the of which there's several. When that happened, all of our transfer switches up on the middle of the building switched because they didn't have any power on the main side.
The emergency system.
Yep. So all the transfer
As they should.
as they should. That worked exactly like it should when they lost the primary. And when that switched over, it energized the secondary side of all those transfer switches.
Okay.
But the secondary side of the transfer switches weren't tied to the emergency power circuits they were supposed to be. In the lower floors of the building, you had the
So
primary.
it was wired wrong.
Wrong. In the lower floors of the building, you had the primary circuit and the emergency circuit.
Yeah.
One was on the right, one was on the left. When they got to the upper floors,
I have a riser for what you said.
when they got to the upper floors, they were switched.
Wow.
But they still ran the primary side and the secondary side, so they were wrong. So when the transfer switches actually switched, they fed nothing.
Yeah, it switched as it should be, but there was nothing on it.
Right.
Wow, that's a design.
It was huge. That was huge.
Wow.
And it took about an hour to get everything energized. Because the Franklin guys, because they lost their control power, normally they sit in the control room and go, oh shit, we lost the F feeder, click.
Yeah, go to the second one.
Right, well, they lost the DC control side, so you've got all these Franklin guys, you never see the light of day, they're stuck over in the plant over there, they're bunch of vampires. They come out with their big control rods and had to go from switch gear to switch gear to switch gear in a coordinated fashion, closing this switch, opening that switch. It took a while for everything energized. It's an ongoing thing because we have all these branch circuits now being fed from. These branch circuits are all supposed to be on emergency power. They're not. All the legals say they are, but they're not. So getting that all switched over is a year-long evolution.
Wow. You guys contact LOTO? I did the LOTO. They contact LOTO?
Oh, I'm sure they did. I'm sure they did.
Once I have, this one, I have the riser there, I know exactly what you're saying.
Yep.
Coming from medium voltage to the bottom, we put the feeders all the way to the 13th floor, if you
Yep.
remember?
Yep.
And then from there, we have substation, and this says all in the riser.
Yep.
And you have to have a normal and emergency on one side.
Yep.
Was it built this way or not? That's a whole different story.
The story that I got was the Hunt electrician. A certain crew took it to 13 floors.
And another
crew came in.
No
and-
coordination.
Exactly. And that transition from 13 up, that transition was reversed from the normal power feed to emergency.
And did commissioning on the building?
You would think all that would be copy commission.
That's what we do commissioning.
Exactly.
That's all the stuff.
Exactly.
Interesting.
You gotta remember, I'm a really low level electrician, so that story might be completely wrong, but that's what I heard.
Yeah. So the story I heard from some of the Christians, the ground fault of 277. Anybody involved in that? Yes, anybody involved in that? The ground fault of that 277 light fixture took down the 1200 amp switchboard, which could happen if you don't do it.
If they're not
coordinated. Yeah.
Yep.
So,
If it had been started from something like that, I would know for sure
yeah.
what it was, and I know it wasn't.
Wow.
I know it wasn't.
Okay, guys, we can come back, please. Thank you, my friend. So we can literally get out here at 6 o'clock.
Our overtime, listen to Chad.
Are you guys union shop?
No.
No union shop? You're exempt employees, so we can work you through that.
No, we are not exempt.
You're not exempt hourly?
Yeah.
Hourly.
I don't know what the guys wearing ties.
Yeah, no, we're hourly.
Hourly. Okay, guys, can you come back here, please? Okay. Now we decided, guys, the safest way of working on energized equipment is to work on it on electric equipment is good to de-energize. That's the rule. Now this is, and we talked about how to do lockout tagout procedures, the complex one and the simple one. Now this one, if you decided, if your employer decided that they cannot shut down the power because it increased the hazard or you can't troubleshoot the system, these are the two reasons. Then you get into what we call an energized work permit. I know you guys do energized work permit. Energized work permit for electric equipment require written work permit. You have to have written energized work permit. I'll show you a few things about it. Here's an example in Annex G here, and that one, or J. And then right underneath the, so we'll talk about this one in a second, guys. I'll show you the example in Annex J. Written work permits, exemption. I like to talk about the exemption before. When are you exempt from this one? Work in the limited approach boundary. Now you open the switch here, right? And you're doing troubleshooting, voltage testing, and you have you're qualified and you're wearing your PPE. You're wearing your PPE, you're qualified to do what you're supposed to do. You're opening switch here, and you're taking thermal of all these connections. We do it all the time for voltage measurement or current measurement. You're not carrying a screwdriver that day. It's just measurement tools. Do you need a work permit for this one? No. That's an exemption. Changing the ballast on that boy here at the top, is it an except? No, you change the ballast on that one, you're so hot, 277, you're supposed to have a work permit in it. It's energized. Or opening a can, energized, work permit. Can you see, guys, the limitation of the work permit? The things that you exempt from the work permit? And the other thing is visual inspection only is okay without permit. We do it all the time when we walk into a switch key, we modify it. You know, I did one for Henry County, they want to modify their switch gears, so I was working for Blue Engineers, walk in there, say, let's look at your switchboard, see if we can add another feeder on that. Well, we have to, I'm not a switch gear expert, I need to go there, take a couple of measurements, contact my GE or any of those or Siemens switch gear division on the switch gear that they have, and say, here's what we have, can you guys add to it? So that's what I was getting information. So I'm not taking tools, so visual inspection. If I'm qualified and I'm wearing PPE, I think I'm qualified, but I wasn't wearing PPE at that day because of an engineer. And taking a couple of pictures, that's supposed to be okay, though I did not wear a PPE. You should wear the PPE. How do you guys do the engineers? If an engineer or somebody, when you open a piece of equipment and some engineer will stick his head there to take some measurement, you have to have push him all the way. Burn him? You got sneaky. Give me the camera, I'll take it. Take pictures. So you're supposed to, these are the exceptions. Visual inspection and just taking measurements. You still have to put your PPE, you still have to be qualified, but no work, energized work permit for this. Okay, here's the energized work permit. If you look at this is in the back, guys, of this book. And if you look at this, to be completed by the requester. If you look at this here, whoever is going to request to work on the equipment energized, have to fill all this information: description of the circuit, equipment, and the job location, job permit, description of the work to be done, justification why should we do work on the energized. Anybody knows where this piece of paper goes? This is what you show to the lawyer, God forbid, up on an accident that took the life of an electrician or somebody else. That's where it's very, very important. Safety coordinator need that one. Because OSHA jumps in, you have an explosion, somebody gets killed. What do you think part of your electrical safety training program that you have is to have this? You have energized work permit. Very, very important. If you have it, your chances of surviving a lawsuit or losing your license as an electrician is higher. I'm not saying it's not going to happen, it's higher. So justification why you can't work on it energized during the scheduled outage, and you're going to sign it. Requester title and the date. Then you get into here. This will be completed by the electrically qualified person. Detailed job description, what you need to do. Description of work practice, practices to be employed. And look at this, shock hazard analysis. Have you done the shock hazard analysis on the work? So you have to go get the limited approach, restricted, prohibited, necessary shock personnel, other protective equipment that you have to do. This is when you get into, yep, I did shock analysis and I grabbed all of my gloves to protect me from shock and my other gloves to protect me from the arc, right? And I have my insulated tools, fully insulated tools, and all this good stuff, justification. Moving on, then you have to go the flash hazard analysis. One shock and one flash. Now for the flash hazard analysis, you need the incident energy and the hazard categories is 0, 1, 2, 3, or 4. You have to verify that one. And this is your arc flash personnel, the protective gear that you need, and the arc flash boundary. I did the calculation, and I know this piece of equipment is going to have a 2-feet arc flash boundary and sign all this stuff. You check, yep. Can you see that this is going in front of a lawyer? When you check all these boxes, imagine checking one and something happened, and hire another electrician and engineer to review it and say, no, you said it's category 0, this is category 3. Oops, that'd be a bad idea, huh? Bad day for somebody. Okay, filling all this information, and then means employed to restrict the access for unqualified people. People are walking on the street for an opening a panel right here. You barricaded the area. Outside, you have to put the barricade outside the arc flash boundary. So somebody, janitor walking in, they're going to burn because of arc flash. You think of the public too, if you're in the public area. Or close the door. Evidence of completion of the job briefing, discussion of the job related. Every job in any secret book, guys, every Energized job, or any job as a matter of fact, you have to start with a job briefing. So we have to have somebody in charge, say if there's a master or a general in charge, you have 2 people working with them. You sit, you talk about the job, what are we doing, what's the hazard involved, what the PPE needed, have we barricaded the area, all this, and there's a nice job briefing example here. You guys have this book, really nice. It goes into details. What do you need to say about job briefing? So have you done that? Yep. And do you agree that the above restricted work can be done safely? Look at that. Is that a lawyer question? Yes. You're in trouble if it proves otherwise. And electrical qualified people you're going to sign it here, and then right underneath it, your manager, safety manager, general manager, maintenance engineering manager, and electrical knowledgeable person, master electrician. See how many signatures we have? You guys do that when you work with Energized equipment? You have to. Do you see it's if you put all those people, I guarantee you, every one of them is going to sign. Well, hopefully, what, 1, 2, 3, 4, 5, almost 5, 6 people signing that piece of document. Hopefully, somebody will figure out that there's something wrong before you work on it.
This is good for the next day.
Is this good for the next day?
Yeah, because this takes all day to put it. So
Confidence.
then you gotta use it the next day.
You got, the next job you mean?
No, the next day. Because this takes one day to fill out all the paperwork.
Oh,
So then you can work on it the next day.
See, one thing we found with a form like this, where people say you have to work on stuff that's energized,
yeah,
you show them this form, and, oh, well, I guess you can't shut it off.
you can. That's exactly what.
You know, they don't want to fill that form out.
Yeah. Do you know why?
The request.
Do you know why? It's liability.
That's right.
It's all about liability. You will sign your name paper, you're liable. You know, all the managers and everybody else, I have informed you, and you, the one who's going to perform it, has to write that I cannot do it energized. If you look at the top, the most important thing here, justification. So that guy who requests for you to work on it, the manager or whoever, have to fill this piece of request. He has to justify why he can't work on it. Justify it. Inconvenience is not just a good justification. So yeah, it gets people scared because now you put your name on a job. Somebody get hurt, you're liable. And that's the whole idea of it. That's the whole idea, is to make people really scared. You know, you're in the premise working for me, go work on it hot. If something happens to you, too bad. You know what I mean? So that's really Energized electrical work permit. So any comments, guys, about this one? So this is a big deal to work on these questions. Any comments, any questions about that? Okay, let's go into limits of approach. That fat, fluffy little book, fat, fluffy, it's not fat or fluffy, it's fluffy. That little book, do you see that picture here? The picture here represents probably 80% of what's in this book, literally. they just flop it after. That picture summarizes 80% of what this in this book. So when you guys walked in, we said there are two major hazards involved in working on energized objects. Energized, electrically energized. One of them is the shock hazard. Now, a single one of us is dumb enough to grab an energized object like this. I need a qualified person. Now, this is for qualified people. Non-qualified people, the public, they shouldn't be there anyway. We're talking about qualified people. You want a qualified person. Do you think any one of us grab an object like this and grab it like this? No way. Qualified people never do it. Even if you're drunk, you're not qualified. Even if you're non-drunk qualified, so. It starts with this point right here. This is your energized bus bar. The energized bus bar, when you open it and you're exposed to the hot. 120, 240, 28, 120, 48, 377, any volt higher than 50 volt or higher. Okay, so we got here, this is phase A. The first circle, guys, or distance that they do it is they call it prohibited approach, right in here. You're going to see it. And the area inside the prohibited approach, typically a couple of inches. So this is the tools space. The only thing, here's my phase A, and the only time I get closer a couple of inches from a phase A energized object is if I'm on the torque it hot. This is tools only. I can't put my finger here, I hope not. Even, you're supposed to do it with tools. So that's a prohibited place, right? So that's a couple of inches from the box. So this is the space, and also this is the boundary. I don't know if you can see it all the way there. So prohibited, tools only. The second one is called restricted. Can you guys see that right here? Restricted. Restricted space, a couple of inches. That's where you are standing in front of the switch here and work on it. That's where you stand and work like that. Called restricted. Prohibited and restricted, nobody other than a qualified person should be in these two places. Actually, prohibited, nobody should be other than the tools. And restricted, nobody other than a qualified person should be there. Done. The restricted. Can you guys see that restricted here? Restricted space here. The second space around it is called, this space is called limited approach, boundary. That's 4.5 feet in front of the switch here. So 4.5 feet in front of the switch here for the most part. And you will see the distance in a second. That's limited approach. Limited approach, only qualified people can be in it. A non-qualified person can be escorted through it. So you work in the panel in the hallway here, you barricaded the area, as you should, and outside the arc boundary, as you should, and a janitor or somebody, you block the traffic, or somebody wants to move in, you're supposed to escort them, stop what you're doing, or somebody would work with you, stop what you're doing, escort them through the limited approach area, out. They're not going to sit there and watch you though. You just escort them through it, becoming an out. They can't just sit there and watch. Okay, so that's a limited approach. And the last one is arc flash. So the arc flash is my favorite. You can see the arc flash can go higher than that. And I don't know if you guys can see that this is the last boundary right in here. That's typically, there are two hazards. Everything else is shock hazard. The one that are highlighted is the arc flash hazard. That's, you're standing right in here, and you're 3 feet away from the equipment, and in short circuit or ground fault, having an equipment, big ball of fire comes and chases you. That's basically what the flash protection boundary is. So that's what, any comments guys about these boundaries? You can see the flash boundary is way at the end. So even if you have the 4.5 feet, you might have to move another foot for the arc flash. And safely, I told the group before you, safely based on the code, the arc flash boundary is 4 feet or whatever the calculation come up with. So 4 feet in front of the equipment or whatever calculation you come up with. That's safe. Now, recommendation from 70E is to stay out 10 feet away from the area, not just 4. 4 is when you might get a couple of burns. 10 is you're safe, completely safe. So 4 is must, 10 recommendation. That flash. Okay, here's how they do it, guys. Inside this box is energized bus bars, copper aluminum. The prohibited is inside the box. That's where you put the tool in, right there, and you start working with it. Nobody other than the tool gets in there. Restricted, you standing right here and working on the equipment. Limited, the space that you need behind you so you can move in and out as you work on equipment here, that limited, where you can just allow the people to walk in escorted here. And the arc flash go beyond the limited. So when you barricade the area, put your barricade, the arc flash comes up to this point. You're going to put, here's my moving away, and this area end will be my arc flash. You will go beyond the arc flash. So that's your arc flash boundary encompasses the whole limitation: restricted, prohibited, and limited. Any comments about these guys? The first three, 1, 2, 3, these are for contact, so you don't accidentally touch the equipment as an unqualified person. And the last one is that big ball of fire chasing, which is the arc flash, 4 feet or as calculated. Okay, these tables come from the 70E. I know you can't read them. I wish I could put them on a bigger. Next time, guys, I promise you will put them 2 per page. This table from 70E right in here, really interesting. I want to walk you guys through a couple of very, very interesting one of them. So you guys are, where did my calculation here? I want to remind you that this is face-to-face, because a lot of equipments are face-to-neutral. Face-to-face, you guys are most of the time face-to-face, you're right in here, right? Typically, excluding the medium voltage guys, you're right in here, up to 750 volt face-to-face. That will cover 208, 120, 240, 120, and 480, 277, right? So right in here, I want to remind you of the limited approach. This is the place where for you to work, and you can escort people through it. So you guys are right in here, fixed, exposed, fixed. Exposed, fixed, things not move. If it's movable, the other one, guys, is movable conductors. That's for the utilities. If you have overhead conductors and they flap and move, right? You apply the movable. Inside the switchgear, have you ever seen a bus bar moving around inside the piece of equipment? Doesn't move. Thanks God it doesn't. You'll have a bad day if it does. So look at the limited approach. 3 feet and 6 inches. That's exact. This is coming directly from the working clearances in NEC code book. Working clearances around electrical equipment in NEC code book matches it. Okay, that's a limited approach. So that's my limited approach. The second one, guys, is restricted approach. That's for the workers. And look for restricted approach. Restricted approach, nobody shall be closer than 1 foot away from the energized equipment, unless you're in the PPE and you're qualified. So that's restricted to the people who are working on it. And the last thing for the tools, prohibited. You can't put your finger there. That as qualified even. This is, in this case, is 1 inch. So get closer than 1 inch from this 48277. You could flash. It could flash. The voltage could jump into the tip of your screwdriver. Doesn't happen a lot in low voltage, but in medium voltage all the time. You get closer to a 13 amp, and a couple of inches, you can see start arcing to the tip of your screwdriver or the equipment. Any comments, guys, about this? So, and you can go see as the voltages, it goes all the way, I think it goes higher than 800 kVA. So it goes, you guys are typically, if you're medium voltage, for the medium voltage guys, so you guys probably, you wouldn't go higher than 15K. You don't have 69, 15K. Look at the limited. Oops. Now you could be overhead. I don't think you guys are overhead. You're underground probably. 5 feet clearances, and look at the restricted is 2 feet 2 inches, and look at the jump voltage 7 inches. You stay 7 inches away from the energized equipment because it arcs. Any comments, guys, about this? This is AC only. Let's look at the DC. Any comments, guys? I asked about comments and keep moving here. It's easy, really easy to use. It's not. Huh?
I'm looking at the big one.
15
foot 5 inches.
Yeah. Look at the distance between 23 feet if it's movable. Well, both of them 23 feet. This is for the limited approach. That's what they put them on power.
Same thing.
Yes. Well, yeah, absolutely. If you got that voltage, you've got to. It goes up to 800 kV. Now, if you're doing 1 million volt, you're on your own. Okay, the last one, I'm not sure if this was in 2000, the before. I don't think this is new. This is for DC. Do you guys have photovoltaic system? DC, where's the phase-to-phase on DC? That's a joke, right? There's no phase-to-phase voltage. So the potential is going to be between phase and ground, between positive, negative. You probably guys will be sitting right in here on photovoltaic system up to 600 volt. So the same thing, fixed, almost the same numbers, right? Almost, I don't know why they have them different, but the same numbers but the voltage is higher now. So you use this one where? DC system. Any DC system. UPS battery, you guys have battery for your UPS system. Up to 660 volt DC or 600, around 600. That's where you apply that rule. Any comments, guys? Any questions about that? How to use this table? Yes, no? Cool. Okay, so that's basically the limited approach and how to calculate the limited approach. Now this is to scare you, and it reminds me of insurance salesmen and women when they come to you and they want to insure you for every single thing. If you die tomorrow, if you don't die, if somebody trips on you and sue you, right? Keep scaring you so you can buy more and more policies. That's kind of the same thing. That keeps you to scare you so you can pay attention to arc flash. But you guys are already scared, right? You're already convinced. I'm talking to the convert here. Arc flash, a couple of things. Arc flash you can arc face to face, face to ground, or face to neutral when you arc by dropping something in between. Typically in low voltage, unless you have loose connections, it's not going to arc. I mean, unless something malfunctions in the equipment, you're not working on equipment, and the equipment is maintained right, it's not going to arc. I would say 99%, I always use an example, your chances of dying from a car accident probably is 100 times higher than your chances of standing in front of a switchgear that's well maintained and taking pictures or taking measurements, and you're not using any tools. Your chance of surviving that one is 100 times higher than surviving a car accident and going home, or your chance of dying in a car accident going home. Okay, so if you arc between electric and conductive material, take this. Incurable burn is 2000, happens at 2000 Fahrenheit. Create cell destruction at 158, and your arc is 35,000. So what is that tell you? If you have an arc, you would have a bad day if you're not aggressive here. That's if you have a day. You might just have a shortcut directly to the other life, for those of us who believe in it, right? So just to tell you, it's going to be hot. It's going to be ugly. Because they want to scare you, and I want to scare you too, these guys in the business of selling books, so and safety too in the process. So in Annex K, they collect information about people who died from arc flash. Here's one of them, 2,000 people admitted to burn centers, not died, because of arc burns. Arc flash can and do kill people at a distance of 10 feet. Remember that distance, 10 feet? Recommendation, even we say 4 or what you calculated is a must. 10 feet is recommendation. Really the good practice is if you have nothing to do with the electrical work, get the heck out of there. Barricade yourself. So a good example here, if you can, is to barricade up to 10 feet away from the equipment. That's good practice if you can. But you must barricade at least at 4 feet. The arc flash boundary. But the good practice 10 feet because that's when you capture all this energy. Nobody get killed and remove the people. A lot of calculation guys here also, most of the electrocution having 11% fatality result. Failure to lockout tagout procedures. So people work on energized equipment, be killed. Recently, wasn't it at the airport where the electrician, you guys remember that one about a year ago or so? And the electrician was working at the airport, and he had the St. Paul airport, and he was found dead. I don't know if you remember that, and he was working in a false ceiling like this, but we have these space where he can work on it by himself on energy. I mean, he got electrocuted, nobody was there to help him, died. So it could be a 277 20 amp circuit if it can't shoot the right way. You just sit and you can't let go, nobody's there to help you, you're done. So electrocution is a real real business, especially I get very scared when I when 480 277. I mess around with the 241 20 regular, especially on the 20 amp circuit. I have to admit, but 480 277, take it serious. That one I've been told, and you guys know that it comes at gradually. Gradually doesn't go at 277. Okay, and this organization found 82% of the fatalities. People were working on hot circuit intentionally. So long story short, they energized before you start working on it. You don't follow the rules. I mean, if people don't work on energized equipment, nobody got hurt. And if you are to work, make everybody sign in so they know that it's a big, big risk. This is what electrical arc flash, I think this comes from Boston. Take this. If you have an arc flash, you drop the wrench and phase A, phase B is arcing now inside the switch gear. They don't arc forever. We're talking about seconds, guys. But these seconds are enough to kill you. How do they kill you? Look at this. You have intense heat coming up to this temperature that can burn you. Okay, now if you survive the heat, no problem. Intense light that we can't see, because you're so bright that you can't see. If that doesn't, so you can't see, you're being burned. If that's not enough, you have bullets chasing you. That's the copper melting and moving at very high speed. So if the heat doesn't kill you and you can't see, you have bullets chasing you. That's not enough. Now you can't hear because the sound wave deafens you. You can't hear. And if that's not enough, you have a big wave pressure pushing you off the ladder. Can't be worse than that, can it? And if that's not enough, you have molten, you're breathing all this stuff and going all the way through your lungs. Now that's you're not dressed up properly for the action. Did they scare you enough now to put your PPE when you're working on equipment? You guys do it all the time. So that's why I always say if you have an arc flash in a switch gear, that doesn't mean you're going to have a good data. Even with the PPE, you might spend a week or a couple of weeks at Mayo Clinic here or any other place where they fix people. But it means your chances of surviving is much higher. But doesn't mean you go home and talk to your friends about it. You're still going to be pushed and thrown against the wall and probably have a couple of burns and bruises all over, maybe a broken arm or something. But if you don't put the PPE, you're not going to go home alive. Really, that's kind of the intensity. Any comments, guys, about the scary tactics that we're using? I mean, it's real. There's a couple of videos, guys, about explosion proof. I'm going to run them at the end. Right here. Have anybody seen that video? Before you guys have seen it, I'll run it. Because last time I ran it and my computer froze, so I'm going to wait until the end to run this one.
Those two guys got their PPE on, don't they?
Not to the, I don't think it's the, this is probably a medium voltage switch gear, and it's they're racking this fuse. I don't think they have a proper PPE. I can't say, I don't think, you have to have a hood in this case. They're not wearing, they're just working construction. This probably they're dressed up for category 0 or 1. And with this probably medium voltage, you're looking at category 4. They survived, he survived though. Time and current. Time and current rating, that's when Busman becomes really cool about selling the fuses. They love it. When you have an arc flash, guys, the arc flash, the severity of the arc flash or arc blast. So we have the flash, they start big ball of fire coming out of it. It melts the copper, and then you have the blast. All these melted copper start going all over, and the sound with it. And the severity of the arc flash, arc blast is a function of the time and the current. 4,000 amps switch gear, you short it. Line to line, say let's get 65,000 amp. How long will it take the fuse or the circuit breaker to clear the fault? Will determine how big of a ball of fire is going to chase you. The faster this ball of fire is going to chase you, the more chances that you're going to survive. I will show you in a second. There's a study that I did for our college, And all these are done in the calculation. These are determined. So for example, when we do our dash calculation, there are multiple software that we use, or you can use the tables, or you can use examples in the back with an Excel sheet. You have to input in the formulas the short circuit, the available short circuit, and the voltage, and the characteristics of the fuse or the circuit breaker. And these characteristics, they call it current carrying curve, and time current curve. Time current curve, you have to get it from the manufacturer. Anybody have seen the time current curve? You have to get this input from the manufacturer. Input it into, like in our software, we use SPM power tools for Windows. Anybody have used SPM power tools for Windows? Power tools for Windows. It's a very powerful software, $50,000. A lot of engineers use it. So when you put all this information, input it, and then it will calculate the available fault current, and it gives you a couple of data. PPE that you're supposed to use, the restricted boundary, the prohibited, and the limited, as well as the arc flash boundary, and the gloves that you're supposed to use, and all of the above. Let me flash, but what I'm going to say here is the higher the short circuit amps and the longer it stays, the more big ball of fire and explosion you have. So that's when the fuse guys say, we're here. We can put a current limiting fuse that can hit you a short circuit of say, 80,000 amp. We can put a current limiting fuse here, and we guarantee you right here on the end, on the load side of the fuse, you're not going to see more than, say, 65,000. So it takes it from 85, say, to 65. They call them current limiting fuses. And they're fast-acting fuses. Like if you have a short circuit, instead of multiple circuit breakers, everybody knows how long will it take a circuit breaker to trip. Physically, they're rated to trip within 3 cycles. 3 cycles are time. If you know what 3 cycles, take a 3 divided by 60, that will be 1/20th of a second. That's eternity in the life of an arc. That's how eternity, literally eternity. So they're rated to trip cycle 1, we're still pumping energy, 2, and 3, now we're supposed to clear based on our lesson. Now those guys, the fuse guys, they say, well, instead of allowing 3 cycles of energy to go right through your face in an arc flash, we can cut it right in a quarter or half of a cycle. What does that mean? It means the limited amount of energy that you're exposed to. And so when we do the calculation, long story short, it takes into consideration what type of overcapacity device we're using. Doesn't mean circuit breakers are bad. But if you are using, for example, if you use a circuit breaker, you might use category 4 to work on this piece of equipment. If you're using a fuse, it might knock it down to category 2. You still need a category to use it. Does that make sense? Doesn't mean if you're using circuit breaker, you have no protection. You will have a higher gear that you have to put on. So with this one, let me just flash these guys and show you. Disregard. And here's a study that I've done for our college. And let me just explode it here so you can see it. Let me just go all the way to a category that, okay, look at this one. Here's a good piece of equipment. This software is really cool, where you can do all the calculation. It gives you a label like this. You can send it to your printer, and you have a label that you can print it on a label and stick it directly to the equipment. That's what's required by code. The code requires you only to have arc flash warning. That's it. A warning arc flash. It doesn't require in any sequence book to put all the details. What requires you to put all these details that you're looking at is 70E. In 2012, they made it very clear that they want all these details that you're looking at installed, and even before, but in 70E they made it clearer that you want you to put all these details. So let's look at the details that you're looking at here. Can you guys see we have, first of all, this is H1 1200 amp DC DC transformer. This, I believe, it's a 480. On the 480 side of the transformer, we have 115-inch flash hazard boundary. Can you guys see that one? Now you can get this one from the table that I showed you. You can get it directly from the calculation. 115 inches. The category, it's a 25 calorie per square centimeter. You can see that one. And measured at 18 inches. At 18 inches, this is what you're going to get. That's the kind of the measuring distance that they measure it. This is where your restricted space is. That's where you're going to be working. Then, what category do I need to wear? Category 3, Cat 3. Cat 3 is listed for up to 25. What's the voltage? The voltage is 480. For category 3, you need an arc-rated shirt and pants, an arc flash suit for category 3. Shock hazard when covered is removed at 480. What type of gloves do I need? I need this type of glove. These are 00. If you look at the gloves here, these are 500 volt gloves, and they're rated for class 00. So you need the gloves. So if you're grabbing on a piece of equipment, oops, this is the left one, not lefty here. You grab with a piece of equipment up to 400 amp. I can grab on this energized object, and I'm guaranteed I'm not going to get electrocuted. Not like you would do that, but you're going to be able to work with a screwdriver like this. So that's the glove that you're going to be using. And then the last 3 things is what we were just talking about, guys. If you remember, we have the this is limited approach. That's where you kick the people. Nobody other than sporty people can go 42 inches. Restricted approach, 12 inches. Prohibited approach, 1 inch. You get all this in one label and you stick it to the piece of the equipment, to the face of that equipment. And right underneath that, you're going to find who did this calculation. Prepare the calculation, the engineer in charge of the electrician, and the date. And based on 2012, you're supposed not the NEC control, the safety control. You're supposed to update this one every 5 years. 5 years. So that's all this information. You can get it from this nice software, or you can. Busman has a little calculator you can do it, and then you can put it in a nice sticker and stick it to your equipment. I just showed you that one. The last thing I want to show here. This is a real calculation. Take this. This one, can you guys see that? Danger. Now this happened to be, we have a 6 disconnect rule in our college. So we have I believe 3,000 amp coming to a switchboard with no main. Out of that switchboard, you have 6 disconnects at 1,200 amp and 600 amp and 1,000 amp going to different substations. So what if you want to work on this piece of equipment that has no main, fuse, or disconnect? It's allowed in the code. Up to 6 disconnect in one piece of equipment, you don't need a main. Not the best safety design. But if you were to work on this equipment, look what we get. Danger. No safety PPE exists. We can't work on that. And the reason for this is because you don't have a fuse. Between you and the utility is only a transformer. The only thing that can trip is the primary of the transformer on the utility side, on the 13A. No protection. So if you have an arc, it's going to keep cooking and cooking and cooking until the fuse or the relay on the 13A see it. That might be a minute and trips. By that time, you're cooked. Because remember that these equipment, this is supposed to protect you only for a certain amount of time, for a certain amount of current. So if you exceed the time, this is worthless. And if you exceed the current, also this is worthless. So does that make sense? So in this case, you can't work on this piece of equipment here, Energized. So look at that, the danger. No fire rated category found for this piece of equipment. And then warning, change in equipment setting or system configuration. So long story short, you put a sticker on a piece of equipment like this. This will not be worked on Energized, period. Any comments, any questions about that? As I said, these are real examples that we use for our college. And that's the main switch gear. That's why 6 disconnect rules that the code come up with is a good idea to save you money, not a safe design. So does that make sense? A safe design had a main. A main, when you have a main, guys, means if you're working on the equipment Energized, the main will protect you. Will protect you. Okay, so that's basically a couple of things, calculation that you can get. Okay, the last, a couple of things this will emphasize the arc flash that you're going to have. A couple of things. Why do we care about the expansion of the copper? Because these are the little bullets that's going to chase you coming from the melted copper. If it's in aluminum, it will melt at a lower temperature, which means if you have an arc flash aluminum switchgear, and the severity of the arc flash is going to be quicker. Because it melts at the lower temperature, more stuff is going to come at you. Look at this, air shock wave can come 700 miles per hour shock wave coming at you. That's enough to knock you off the ladder. Oh, and if that's not enough, the pressure, the sound exceeds 160 dP. So now you can't hear because of the explosion. It's really a bad day if you survive. Even if you survive it, you're going to have a bad day with the proper. Hundreds of pounds or so, enough to lift worker off their feet and into the equipment. So that's why I said you're going to have a broken, even with the PPE, if you haven't had an experience like this, you will stay in the hospital, but you survive it. That's why, what's the rule? The rule is energized. Worker takes the energized. Doesn't mean this piece is going to protect you at all times. You still have to, you're going to have a bad day. Okay, so the arc flash boundary that we were talking about, guys, for voltages 50 up to 600 volt, it's 6 feet, 4 feet, based on 4 feet calculation. Unless calculated, the boundary shall be 4 feet. So you don't do the calculation, you're going to assume the arc is going to go up to 4 feet. And so you have to respect the people getting into the arc flash boundary. And a recommendation is what? 10 feet. Go 10 feet recommendation. So a couple of things: incurable burn to the boundary that will prevent an incurable burn to unprotected employees. That's where the 4 feet. If you're incurable burn, but you will get burned though. Curable burn. You see the word that I use? Incurable burn. You're gonna have scars all and you have cracked skin for you and all this good stuff. If you're standing at 4 feet boundary. Anybody wants to be there? But if you go further than that, you will have a burn, but it's going to be curable. So that's distance is calculated to provide just curable burn to exposed skin at 1.2 calories. So that's the distances. The distance where you will do the calculation, they want the people to get out of it as a curable burn at 1.2 calories per centimeters. So that's why you get into the arc flash, you're going to exposed to, if you're not dressed, you're going to get exposed to a lot of arc. Okay, methods of calculation. So long story short, guys, 4 feet or whatever the boundary is, barricade the area to protect from electrocution and from arc flash. Recommended 4 feet. You have to have 4 feet or recommended 10 feet when you put your boundaries. So method of calculation. A couple of things I showed you guys when we were looking at the calculation. You were looking at the incident energy, arc flash boundaries, and the PPE. You see that stuff that flash? It shows you what the calories are and what the boundary are and what the PPE category is based on the calculation. Then you can go grab yourself this one happened to be 12 calorie. That will cover you up to category 2, I believe. So that's basically the calculation. There's NXD, guys. If you don't want to have this software, hire an engineer to do it for you. NXD has really nice approximation, and if you're good with Excel, you can program these sheets where it can get you the actual incident energy. So you do a calculation, will tell you the boundary is going to go 2 feet. Cool. And the incident energy for this piece of equipment under these circumstances, the fuse is going to rated for 15 feet and it's going to interrupt within 3 cycles or 1 cycle. It's going to give you an energy of, say, 8.3 calorie per square centimeter, and 8.3 will move you up to Cat 3 equivalent, category 3 equivalent. So you can do all this. Hazard risk analysis. That's from the table that we were just looking at, guys. We highlighted 15, A and B. A was for the AC and B for the DC. Protective clothing, we'll look at this one in a second here, give you the protective clothing. If you know that your category is category 0, what type of clothes do I need for category 0? There's a table, you're going to look in a second, that can actually specify this equipment for you. And arc flash clothing, Annex H will tell you what the arc clothing in a second here. Okay, when you have arc flash, based on the label that you're going to have, based on any sequence book, it just says all what you have to do, arc flash hazard, wording, arc flash hazard, period. Done. Based on 70E, you have to go further. Here's the stuff that at least one of the following have to be there. Available incident energy and corresponding working distance, minimum, one of these. Minimum arc rating of the clothes, required level of PPE, highest hazard risk category in terms of shock, and you need the nominal voltage, nominal system voltage, and the arc flash boundary. Long story short, if you can see the stuff that I showed you guys has more than what's even required. It gives you the category, the clothes that you need, the voltage, the gloves, and all that sort of stuff. But minimum, you need one of these plus the system voltage and the boundary of the arc flash. So minimum arc rating of the clothes, required level of PPE, the risk, and available energy. From the available energy, I can get the PPE, and from the PPE category, I can get the rating of the clothes. So they're all interconnected based on the table. Any comments, any questions about what 70E require for the arc flash? More than just arc flash wording. You need the boundaries of the flash at least, and the PPE and the voltage that you're dealing with. Why do you think the voltage is needed on the label? Because of the shock. I can't buy, if my system is 600 volt, I can't use this glove because it says on this glove is rated for 500 volt. It's class 00, and it goes up to a maximum of 500 volt AC. So 600 volt system, I can't work on it. So it has to be 480 or lower systems. Okay, this is what I want you guys to look at. This is from table 130.7c. You guys will do an exercise with your friend Chad today, how to pick the right category based on the circumstances of work. Let's do an example here. Let's just say, I don't think I should. Okay, let's say, okay, this one. Panels, I'm going to use this one. I know you guys can't read it, but the exercise that you have has this one. You have an exercise that actually has it blown up. Let's do this. Pointer, highlighter. Do me a favor. Is this you guys? Aren't you more than 200 volt and up to 600 volt most of the time, right? 208, 480, 277. So let's pick this one. Okay, so let's say this is based on a 25 kiloamp short circuit, and it will trip within 3 cycles. This 2 cycles is, we're talking about a circuit breaker, not limiting switch, because 2 cycles, that's an interrupting of a circuit breaker rating or less. Minimum distance that we're going to do the calculation is 18. 18 is typical, guys. They do the calculation, the category that you're 18 inches from the energized equipment, and big qualifier have. That's how much energy will be hitting my chest and my face and all this calculation. 18 inches typical. Can you guys see that? If you look, if you want to follow up with me, the exercise has all page 3 up, and this for the exercise piece. Okay, if you grab the exercise at page 3, that's where I am on this. Thank you. Okay, so here's the circumstances. Okay, so now let's look at the following and potential arc flash boundaries up to 30 inches. So let's look at a couple of performance. I'm going to look at this one. Can you guys see a circuit breaker fused switch operation with cover off? You have 480-277 disconnect switch, and you're operating it with the cover off. We do it all the time. So can you guys see what the category is for that? Category 1, do I need insulated gloves? Yes. Do I need an insulated tools? No, I'm not working with tools. Do you see how you can use, based on the action they're going to do, which category and what type of gloves and tools you need? Let's choose the one exciting one. Removing, this is my favorite, removing or installing a circuit breaker or fuse switch. Now you're doing big boy work, right? Could be 15 amp, little boy, or it could be 500 amp, big boy work. So look at the category. Am I reading it right here? Category 2. Category 2. And do I need, by the way, rubber insulated gloves? You betcha. Do I need an insulated tools? Yep, you're installing a circuit breaker. Can you see, guys, how to use this table? To specify based on the action. That's if you don't want to do the calculation that I did. I showed you the label. But based on what you do, it will tell you what type of hazard are you exposed to. So in this case, you're looking at gloves like these. And so you will put your gloves like these. This is to protect you from electrocution. If you use this one in an arc flash, what's going to happen to these? They're going to melt in an arc flash. To protect, this is just to grab things hot. So to protect you from these, from arc, this is to protect from shock, electrocution shock. So to protect you from the arc flash, you have to stick these in a run like this. Not a lot of work, huh? To work on equipment. So you stick it. Now, if I can't put my fingers in it, it's clumsy. There you go. Now you've got protection from electrocution shock as well as from arc flash. Make sense? And then you grab a tool like this, fully insulated tools. You look at these and say 600 volt. It should. If I can read here, where are we going? Distribution. Well, this one was at 600 volt. 600 volt. Yeah, this is 1,000 volt on it. I can pass here. Pass that one if you guys don't believe me. And this one should be up here, 1,000 volt. These can work up to 1,000 volt. We'll talk about tools, guys. This one, no voltage in it. This means it's not insulated tool. Can't work it. So you can work on insulated tools and gloves. And category 2, this will get you off to category 2. So you can grab this one here, and you will put this one, and do your work. That will be a large one, right? Put this baby on you. This is 12, category 2 up to 8, so you're good. And you put this shield on you, and you're good to work on installing this fuse. Any comments, guys? Any questions about that? How to specify the equipment and work on them? Any comments? Any questions? So now we have an exercise for you guys. I'm going to be using how to use this table. Tells you here's the scenario. What category do you need? So you can specify the clothes that you put on, and the gloves. Do I need gloves? And do I need insulated tools? Isn't that cool? Am I the only one who's excited here this afternoon? Aren't you guys excited? Oh my God. This is why you go to, I'm sure there's a couple of supervisors here close to years. You go to your supervisor and say, we are like fighting in Iraq here. This is war, man. Standing and work on it. So what does that mean? We need grades. Oops, no, they don't need grades.
You guys love that.
Huh?
You guys love that.
Oh,
Not
we
till
still have 2 hours.
5 o'clock will be on.
Almost. You had this for another hour.
It's 4. 2 hours, yeah.
Okay. So, okay, I'll check on that. We'll try to find another.
Okay, thank you. Sorry. This is 402, right?
Right.
Yeah.
This is 402. Okay. Now that you guys, now we get the category. So for example, I'm changing the circuit breaker. I have 2, right? Category 2, gloves, as well as tools. Now you go to another table here, 130.7C16. It gets you what does category 2 mean. So let's look at category 2 here because we looked at it. I don't think you have that one, guys. to you?
Yeah, page 6.
Page 6? Okay, so I lied to you again. Here's category 2. And if you look at category 2, guys, you need the following. Look at this. You need an arc rated clothing minimum arc rating of 8 calories. So would that work if it says 12 on it? Minimum 8, yeah. And would that work if it says, what does that one say? This one says 8.2. That will work. Both of these will work to cover yourself. And the second one, so look at what they do, guys. Oh, okay, where am I here? So we need an arc-rated sleeves, long sleeves, and pants. Or overall, we need an arc-rated suit, hood flash, or arc-rated face shield, rated for category 2. And we need an arc-rated jacket. And for protective equipment, I need a hard hat and a safety glasses. Does that make sense, guys, with these categories? Okay, so that's basically what category you need and what equipment that's gonna protect you. The shield, the overall. This one, your overall, that covers the whole deal here on you. Category 2, right? Category 2 will get you up there. And with this one is 2, will get you there. And with the says 2 on it.
Glasses.
And you need glasses.
Yeah,
Safety glasses.
yeah, so that's in people from Melton.
Safety glasses. I think you have to have safety glasses over your glasses.
You've got a safe glass on the side of the road.
And that's all, yep.
But they gotta be ready, so they don't know. They gotta be ready. And they forgot it.
Fire rated safety glasses.
Says that's not safe.
Is that what says fire rated on them? It says safety glasses or safety glasses SR. SR is, what is the SRS specified, I think, or they have a category selection required. So you have to select the proper one. Heavy duty military drop. Okay, so that's basically a couple of examples, and you can guys go through that. With the equipment that you need, the gloves and so forth. Any comments, any questions?
What does say heavy duty leather glove? What does they make of rubber?
Rubber gloves is for working energized, right?
Oh,
This is for the arc. So if you work with which it goes side by side. If you're working on energized equipment, you're going to have an arc. So this is where you're going to get the two together. One for shock and one for flash. This one is more concerned about the flash. Any comments, guys? Any question about that? Okay, so that's a couple of things. The last one I want to flash here is a DC. If you're working on your DC system, see DC equipment, and let's just say you guys, voltage right here. I don't know if you have, I don't think you have this. You're looking at voltage up to 600 volt. That will be probably you. You're looking at 2 seconds to interrupt at 18 inches distance. And you're looking, if you have the short circuit between these two values on the DC side, and arc flash boundary of 36 in here, what do I need? So working on energized electrical conductors and circuit parts. So you're working on energized conductors, including voltage testings, where the arc current is between these two values. So what do you need in working energized equipment? You need category 1. Do I need rubber gloves? Yep. And do I need insulating tools? Yes. So this is basically for DC. Same thing. The one that we flashed, the first one is DC. This one is for AC and DC. Any comments, any questions? So you go to the action, decide what category you need first, and then you go to that category. The category will tell you fire-rated pants, overalls, or shield, and so forth. And I don't pretend to be an expert in all these guys, but they have a lot of specification. This one says category rated at 8 calorie per square centimeter. Sure, we can get them higher than that too. And then you go to 3 and 4, then you start covering, having the whole hood over your face, it's not just a shield. Any comments before I give you a quick break, 5 minutes? Comments, questions? If you're awake, huh? 5 minutes? Okay. Oh, you didn't get your stuff? That's what happens when you come late, huh?
Cover my bag for about this week, just inform my boss.
You didn't use it? Where did you put them? I put them.
I've already read it, but it's nice to have it fall off. I got this book too.
Oh, that's good. That's awesome. You know what? Let me see.
So the online calculators, every one I tried comes up with different results.
You know what? It really,
And I'm just scared to have you around start figuring that stuff out. Well,
this one,
know that, figure out each panel.
the labels.
Yeah.
You almost, you need, this is an engineering job. Really, it's to get the labels. Did you see the labels I flashed?
Yeah.
These are coming from the software. It spits them all for every code. I have the one I
There's
just
a software.
Yeah?
I researched the
Did you?
software too.
Yeah. It's
Yes,
expensive
ma'am.
though.
Easy power and what's the other one?
Easy power. I like SCM. We use SCM a lot. Let me see, but I think I wrote on one thing. I just want to make sure I did not write on which one did I write on. There you go. Yeah, that's it. That's yours.
Okay.
Keep you awake, then, huh?
Yeah, well, this is one of the safety committee told us to come over here. We were gonna, laboratory, but don't deal with any of them, yeah, but they said, because I think it's still like a 50 to 600 grams, they said we have.
I'm sorry. It's boring.
Well, no, that's okay, it's interesting, you know, but, yeah. Yeah.
They don't have a background, electrical background.
We got like much.
Yeah, I mean, if you don't know what our fault is, because we calculate that's just our fault. And we have, oh my God, we have a whole software that calculates that available our fault. What we do is we have nice software, we put up every single panel that we're building, including the feeder that comes from the utility into this software. Then you run it and it will tell you every single panel you're building is, if you have a short circuit in panel A, that's not our current thing to do. So it takes into consideration, let's have a short circuit panel A, do calculation. Panel B, do calculation. So with all these numbers, that's what's going to happen if you were to have a short circuit one at a time on every panel. And then based on this, it takes, okay, now let's have an arc flash. Arc flash will be slightly less than a whole circuit breaker. And then now let's calculate the energy that's going to come out. There's a lot of math. And the whole idea really is just to make sure people go home safe.
Yes. Got a lot of respect for electricians. Yeah. I'm glad those guys are doing it.
You'll be, I do training for North Star Steel in St. Paul, one of the largest
and milk it and make robots.
That's the business. So there's the shredder, they call it. The shredder is driven, all these knives that cuts through the cars into pieces. It's driven by a 6,000 horsepower motor. 6,000, not 600, not 60. 6,000 horsepower motor is the size of that boy. Half of this room, probably the size of just the motor. And then that's the size, the horsepower size, the power. And then it's driven by 4,160 volts, very high voltage. So I was there when their electrician, it was off. Now they racked these circuit breakers, they racked them out, pull them out. They energized the equipment, they pull it off, they want to do something sitting on it. When they're done, I was there when they were racking it in. So they rack it in, now it's completely in, and they're dressed up. And they push the button to engage it. When they engage it, I literally, the room was shaking for that piece of equipment to come along. It's an experience to see, and that's no important. Wow, shakes when you start that big boy.
That's a lot of power. Yeah.
I have respect for them when they went in and said, I know how it works, and man, those are the guys, they're all alive. If that thing is to fall, he probably, his chances of surviving, even with the gear, is nil in this voltage. He might get his broken neck or something. So. Okay, is my 5 minutes out? You give them 5 minutes, they take an hour.
I don't wait for you to tell them to come back in.
Okay, guys, we're staying until 6 o'clock today. That will get their attention, huh? That will get their attention. Okay, so incidents. I don't know where this picture is taken from, but there's a lot of incidents, guys, where when you have a short circuit or a ground fault, this is how your switch gears will look like. You guys have incidents like this, where it's burned, completely burned. This is good. The electrical equipments are rated if you have a fault to absorb the energy and not exert the energy outside the equipment so it kills personnel. So this is a good outcome of a short circuit. Where nothing open, all the energy got absorbed by the equipment. Now you're going to go change the switch gear, but nobody got killed. Changing a switch gear is one thing, and killing a personnel is a whole different animal. So that could be an arc fault inside this piece of equipment. A couple of things, guys, about going back into the limited approach boundary. Only qualified people can work on it. Unqualified enters the boundary space. Qualified workers monitor and advise the worker of the danger. I talked about this one before. The limited approach, you can pass through it, being approached and monitored by the workers, but you can't stay there. So you have to be monitored and advised of the danger in the limited approach. This is just a couple of things, guys, about causes of burns due to arc flashes. There's a video you can see. When you have an arc flash, this equipment, you have a lot of heat, so the equipment are going to catch fire. Clothing ignition due to heat and or molten metals. They actually rate them by, if you have a hot molten metal here, how long will it take it to cut right through the fire-rated jacket that you're wearing or overall. Incident energy on exposed flesh. They do the whole calculation that could burn you. Molten metal on exposed flesh also. Clothing metal onto the flesh or heat penetrating clothing. All these are causes of burns. So as I said, they're really interesting to when they fire rate them, they take it to a melting big fire coming over here. How long will it take it to burn through this piece of equipment? And whatever you're wearing underneath it, typically you wear something that's not that cotton or something that doesn't stick to your skin. How long will it take it to burn right through it? And that's how they rate it for 8 calories or whatever, or 40. Again, a couple of things, guys. The whole idea of when you dress up with these and you put your clothes on it, jeans or whatever. So if you want the fire, this to catch fire because of very high energy and so forth. You don't want your clothes also to catch fire and burn your skin. So they go through a whole lot of calculation on weighting and so forth. This is some statistics. chances of survival from burn injuries. Look at this one. If you are a young fella and if you have burns up to 75% burns, your chances of survival is 60%. If you are also a young fella and you're 59 years old, your chances is 20%. So what does that tell you? It tells you this type of hazard is a young man has, for the most part. It makes sense like every other injury, because the older we get, the longer it takes us to cure, based on age and the severity, as well as the survival. Who cares about all the statistics? Is we take it serious. Especially the older we get, the more serious we take it. Restricted approach. If we're in the restricted approach boundary, this is live conductor, restricted tool, qualified people only. We talked about this one. That's a no person shall enter it unless you're qualified. Under no circumstances, unqualified people can allow to cross this boundary. Qualified people also, you're qualified first, no unqualified into restricted approach, which is like a foot in the front of the equipment, energized. And you have to have a training for the equipment and proper PPE. You have to have the proper PPE on you and train how to deal with this equipment. Plus, that's what part of being qualified, right? Any question as well restricted? I mentioned this as we were talking about the restricted. We keep emphasizing the prohibited. Look at the prohibited. Prohibited minimum distance considered non-conducting. Any closer can do a flash over to conductive parts, and is considered same as making contact. So you get closer to an inch from that one is as if you are touching the hazard, the electrocution hazard. So this becomes almost tool. You just tip of your screwdriver or your plier. You're working with equipment. Required qualified person have specific training on the voltage present and precautions technique used to avoid the exposure. PPE is required. For the system voltage is required. You have your PPE, and you also have to which voltage are you dealing with. And is this piece of insulated equipment rated for it? I can't use this one at 15 kV switch view, right? Because it says 1,000 volt in it. You have to understand the voltage limitation of your equipment that you're using. Any comments, guys, about this? Repeating the prohibited, restricted, and limited approach criteria. We tell this to our apprentices all the time. You guys can repeat this one to the people. If you see all these chains around people's necks and earrings and all this good stuff of working on electric and working on energized equipment. So this is where in 70E 130.6D tells you all of these conductive things that you can add to yourself, you have to remove them. The last thing you want to do on an electrocution situation is to make yourself more conductive, so you can run more current for yourself, so you can do it like that, basically. So in order to avoid this, all these things have to be removed as you work on the equipment. All should be removed or covered. Watches, rings, earrings, and I'm sure you guys know that all the time when you work on it. That's a good excuse not to put your ring. If you don't have a ring, if you don't want to put the ring, a good excuse for your wife is, well, I'm working on Energized. That's only if you're working on Energized, which it should be the exception, not the rule. But for you guys, it might be the rule. Keychains, eyeglass with metal frames too. So all these have to be removed. Electrical contact. This is the shock. We know what happened in the shock. It pushes you, it burns you, it deafens you, it blinds you. It's a bad day. So you have to put all these equipments on it. Now, what happens if you touch? You don't have the explosion. If you wrap the phase and say that when you touch it, it's hot or not, right? Believe it or not, there are people who do some things like this. I went to school now. This is when we were in college and we were kind of stupid sometimes. I had a colleague of mine, mechanical engineer, makes fun of the electrical engineer all the time. So we had a heater in his dormitory, and he wants, of course, heaters in dormitories, kids take care of things. Wires are sticking out there. Voltage to 20. So he used to joke, and he goes and touch it like this. As you see, there's nothing here. I literally touch the phase. Now, if you touch a phase of 220, just touch it, you get a little tingle and it doesn't turn. But that's how, to prove that electricity is not. Now, when you're 19 years old, you do a lot of stupid things. That's one of them.
So how do you touch something live? This is old stuff.
How do you touch something live?
You never touch it like this, you only touch it like this.
Yeah, because this is grab. Yeah,
Because this way you can reflex it to push
you
it.
grab it, yeah.
You go back at it, you come this way.
Well, the rule is not to touch.
That's right. But this is stuff they taught years ago.
Yeah, you touch it on. You don't touch this one, because you're right. Your muscles will close and you grab onto it, and I can't let go. You have to right. But the rule is not to touch it. So if you want to make contact, burn skin tissues. That's the first thing that we have. You're burning skin tissues. That's the least of your problem. The worst problem is disrupt the communication between your heart and brain and muscles and all this good stuff. All in a second, you have a 60 hertz going right through your body and interfering with the communication system, internal communication system. Up to this point, who cares? I send the signal to my muscle to remove my hand away from that wire and it doesn't respond to me. That's a bad deal. When your hand doesn't respond to you, your wife not responding to you is one thing, but your hand is not responding to you is a bad thing. Including hearts, lungs, hands, eyes. So you can't, your heart will stop if it's too severe or your hand can't respond to you. So you can't let go, and eventually, you turn into a hot dog. So that's basically the electrocution. You guys, there's a lot of videos. There's a video, scary video, crazy guy in Delhi, in India. Anybody have saw that one? On the top of the train, and everybody's calling him, and all of a sudden he makes contact with energized high voltage, and then you get burned. Another guy climbing the tower, all high voltage. Now, here's what I think about high voltage and low voltage and high current. I always say high current can kill you. You have high current at a higher than 50 volts, that's enough to kill you if it stays there for a long time. Now we're talking about contact, make contact with it. When you're grounded or you go hot to hot. That will kill you. If you have high voltage, very low current, torture. You ever seen you can torture you, there's not enough current to kill you, to cook you internally, but not enough voltage to torture you. Now you put the two together, that's the utility work. High voltage, high current, it will eliminate you. It completely just disappear. Turn into, and these are all the examples of people climbing the towers and cracking phase A and phase B or phase A and the pole. So it's unreal. If you jump and grab on one hand, one phase only, you survive. Don't do it though. Anybody?
Because when you let go, you're going to fall. You hurt.
Yeah, well, that's a fall protection.
Yeah.
You need a fall protection.
Don't tire out.
Another class for OSHA. Another OSHA class. Okay, this is physiological effect on the body in terms of current. That's why, guys, or GFCI. Remember the GFCI sit for 5 to 6 milliamps. So this is, you just can't feel it. Little damage from brief contact up to this muscular contraction, difficulty or impossible to let go. And you can see how the current, and I can't emphasize, we're talking about milliamp at high voltage. We're not talking about 12 volts. Now milliamps at 120 volts. That what it could happen to you. Now at a higher voltage, it cooks you faster. All the way up to 0.2 of an amp. Look at that 0.2 of an amp. It sends you to the second life fast. If it grabs on you, and it's all function at the time. If you can let go, not long time, you can let go. But if it grab on it and sit there, it's enough to, to stop your heart and move to the second life. So this is just to emphasize something that we always know there about don't touch energized objects. Anybody can admit that they touched the shop? No, I told the group before you. I counted, now I've been in the electrical industry for 21 years. Not a whole lot, but I counted 20 times. Literally, I got shot. And most of them when I was stood. I bet you 99% of them is just ignorance or arrogance.
What was the other one? Dare?
Huh?
What was the other one? Dare?
Yeah, no, the other one is somebody else that should have done something. But I remember 19, I'm working on a lamp, 220 amps, 220 volt, and you know what these lamp sockets, if you push them too hard, that lever at the bottom goes back and it doesn't make contacts, right? I've seen that all the time. See, as easy as just putting a screwdriver underneath it when it's steering, you know, so push it up. Well, I decided to put my finger underneath. I thought I unplugged it. Well, it was plugged in, you put your finger in there, you make contacts, and I was grounded. You got a really good shock for 220. That was the worst. Another one, we were changing meters, with, again, 220, that was in Jerusalem. And I'm working on this big panel full of meters for the owner. Wires all over, you want to meter all those kids. It's a college dormitory, and you want to meter all the rooms. Anyway, and there were wires. One of them was hot. Everything was hot. So short sleeves, and my arm hit the hot conductor, and I'm grounding. I'm holding on the other side. I got a really good shot. These are the bad ones. I survived though. Tell about them. Don't try it. I'm less smart than those I was young. Okay, so a couple of things that also you have to pay attention. Now we're working on energized equipment. If you're working on energized equipment, you have to have something called release training. Workers who are likely to be exposed to live parts must be trained on how to release victims from the circuit, what emergency procedures are to be followed. That's part of the debriefing and electrical safety program that you're going to have. What happens if somebody got electrocuted? Now, there's no big arc flash here. Or big arc flash, what are you going to do? Can you practice CPR on them? Do you know who to call and 911 and do you know the address that you're at? A lot of electricians, you might be in a place you can't tell them what the address. Granted, sometimes they can't pick up the address through the phone. So all these stuff you have to be, if you're working at a place where people get electrocuted, you have to pay attention to that one. Tools, we talked about tools, guys, insulated tools and non-insulated tools. These are two screwdrivers, look almost alike. One of them is voltage insulated and the other one is not. For people who are not in the industry, look at them, look exactly alike. This one you should work with the energized circuit. This one you can't work with energized circuit. How do you know? Not just by looking at it. If you look at this one, there's nothing that says that this is voltage insulated. This is upward grid that they have here, and this is extra safety for you, not voltage insulated. Though if you work with it on voltage, it's still giving protection. This is the one that you're supposed to use. Why? Because if you read right here, it will tell you this piece is rated for 1,000 volt. Right in here, 1,000 volts. So meaning I can work up to 1,000 volts energized. And of course, you not with bare hands. You have to use the gloves and the leather gloves too. Same thing, guys. Two pliers. This one is not voltage insulated. This is comfort right here, and this one is voltage insulated. How do I know? You can read the description. It says, yep. Typically they're orange if they're voltage insulated. And this is probably, 3 times more expensive than this one. It does the same work. But why? Because this now I can grab and tighten certain things energized. Now granted, you still have to have a PPE and gloves and everything else. There's a mechanical. Any comments, guys? Any questions? Any comments? Any questions? So these are a couple of things about non-insulated tools versus. And we call them voltage insulated, just to distinguish between them. This is voltage insulation right here, and this is no volt. This is insulation, but not voltage rated insulation. I can't use this one in a 15 kV switch gear because this is 1,000. So it makes things put things in perspective. So here's how it look like. These two that you guys are looking at. We talked about the PPE, guys. We said the PPE have to protect your body, hand, face, and eye protection. Most of the stuff, almost always the eye protection with a goggle or something. Face sometimes for category 1, 2, and higher. Hands protection, almost always for all the categories except category 0, where you don't need hand protection. And the body protection is what you're looking at here. Clothing should be arc rated and should not support burning. So it should arc rated, doesn't allow to cut through it and go through the skin. Steel toes, you have to protect your steel toes so they don't get conductive if you are to get electrocuted. Some type of leather covering and so forth. Shock resistant shoes when working on live power and so forth. Shock resistant shoes, rubber shoes and so forth. So these are a couple of things that you can use to minimize the shock, the actual shock. Any comments, guys? Any questions? Comments, questions? Employee clothing. A couple of things we said shall ensure that the employers. Now, this the employers and employee for the employer's responsibility. Your employers to ensure that the clothing worn by the worker exposed to possible flames or arc will not increase the extent of the injury. So the clothes that you wear under these fire-rated clothes, it has to be a clothes that doesn't increase your injury and burn, right? Things that doesn't melt on you and stick to your body and doesn't burn fast. Example of these, clothing containing these could not be used. All these nylon and so forth, because it can melt and stick to your body. Unless treated and certified as fire rated, of course, and I'm not getting into the material that you use and all that stuff. There's so many certifications. As long as it's fire rated, you were just showing me that shirt that you are on is fire rated, and it has a label on it. Cotton is a good example of that one. Hair nets, head covering, and hard hat liners must also be fire rated. So a lot of equipment, guys, have to be fire rated as you wear them. This is protective clothing. We looked at this one, guys, 150.7C. I picked this one because of the last category, as a matter of fact. I'm going to flash this. I don't think you guys have, oh, you have this one in page 7. Oh, wow. You guys are paying attention here. Now, this is the worst of the worst. You're at category 4. Look at what they want you to do at category 4. I want to highlight this one. Category 4, you need 40. This is rated up to 40 calories per centimeter. That's how much energy can sit on 1 centimeter squared, and it can handle it for a certain amount of time, of course, not forever, you know. And this is where you get your fire. And most of these guys, they can list them, you know, the arc. Remember, the whole arc and the flash should end within 30 cycles. I mean, we're talking about arc flash comes within 30 cycles. The circuit breaker will trip, open the circuit, and the arc flash went down. So maximum 30 cycles. A lot of equipment are within 3 cycles, which is 1/20th of a second. It interrupts, and then the whole flash is going to come to an end. It's not like something's going to sit there forever. And of course, you're going to be removing from it. Look at what they need, guys. The first long sleeve arc-rated pants and shirts, coverall, arc suit jackets, flash suit pants. These are equipment that you need. How about hood, flash suit hood, gloves, and jacket-rated rainwear, if any. This is as specified if you're working in the rainwear. And protective equipment, you need a hard hat, and you need a glasses, and you need a hearing protection, and you need a leather work shoes if you're working on. This is the worst of the worst, and I know you guys have that category. So that's as bad as it gets. So probably most likely this is like working, trying to rack, put a circuit breaker in action, 4,000 amp switch here, trying to change the fuses, energize on it, open it, and you put a fuse. It's a fuse. You try to put the fuse over there up at the 4,000 amp switch here. That's probably taking to category 4. Any comments, guys, about using this table? So there's one table to tell you if you're doing this action, this is the category that you are in. And then when you get the category 0 through 4, this is what you need to dress up to work safely on this energized equipment. Okay, here's a couple of examples, guys. This one happened to be 11 calories per centimeter. This will get you as high as, anybody remember? We have a slide that summarizes the whole category for you, really cool, in terms of calories per centimeters and category, 0, 1, 2, 3, 4. You're going to see it. This will be category 2. Category 2 can cover you, shield with, huh?
Yeah, after that, it's good.
After that, you get into the hood. Here's what I want to emphasize this one. A couple of things, guys. This is category, I want to emphasize the worst of the worst. Here's this one. This is what you should look like when you're working category 4. Now, how productive can you be when you're working on this? So this would, your productivity probably goes down to 1/10 of what you're doing. But a lot of people use this one to rack a circuit breaker in action. Work really, really when you need it. When you get to category 4, you shouldn't use it. I've seen it done. I was just telling a couple of gentlemen here, North Star Steel, they have a 6,000 horsepower motor that burn it at 4,160 volt. When they rack that medium voltage circuit breaker in, dress up like this, they put the circuit breaker, rack it in, and push the button to energize it. That could explode at any, whatever, there's a ground fault. That's when you need something like this. So that's the worst of the worst. Then category risk 2 or 3, it depends. Then after that, after 3 and 4, you start getting into the hood. This one is category 1, and I believe also 2. You can get up to 2. This one, I have that one in front of you, 1 and 2. And the last one right here with your face, nothing or no protection, that will be category 0. Category 0, glasses, and just a hard hat, or glasses only, no hard hat. And that will describe, so you start going to category 2. This is when you start putting the shield over here and then the hood over it and so forth. Any comments, guys, any questions about that? Any comments, any questions?
A question, when you use the hood, is your shield not under the hood?
I thought the hood is part of the shield, isn't it? It's built right around it. You can see that.
Yeah, you don't want a shield underneath your foot.
Yeah. But you put goggles though, glasses, safety glasses, yeah. So it's the shield is built in part of the hood thing, and that's when you get into the category 3 and 4. Okay, this is one of the most important things, guys. Remember this one for the exercise I'm going to give you, because it's going to be, they're going to ask you if the calories are this, what's the category? So here's the cheat where you can get the answer. So 2 calories, guys, is category 0. That's where the up to 2 calories, that's category 0. That would be just dressed up like this gentleman here on either these occasions. That will be category 0, really not a whole lot. And then category 1 is 4 calories, the energy. 2 goes up to 8, and 325, and 440. After 40, good luck. I heard that they rate some equipment higher than 40, but it's not recognized electrically. So like the switch gear that I showed you at Dunway, that you shouldn't work on it. It's higher than 40. Any comments, guys, about these rating? What the calorie correlated with the actual category? So 5 categories, 0 through 4. I hate to show all this stuff, but this is what could happen if you have electrocution and you have arc flash. I don't like to show the stuff, the graphic stuff. If you want to see all this, did you guys, there were pictures, unreal. Most of these, the worst thing could happen in the high voltage. A couple of guys, you guys had about a couple of years ago, right in St. Paul, they were putting a high voltage, I think 150 kV cable. And somebody, actually a construction worker, saw that big cable full of copper. So he was working, I don't think he was an electrician, a construction worker on the side, came back at night to steal copper. So he tried to cut, he has tools to cut through a medium voltage 150 kV cable. And he was energized. Long story short, it shut down the whole cabinet. guys hear what a couple of years ago, he shut down he took down the whole distribution point capital, and he got fried right into that trench. So it's amazing how people, we try to go, if you sort of, look up, you steal some copper, but you tell yourself the process. There's a lot of stories like this, people get into, especially medium voltage substation, utility, you walk in, they try to cut some cables, to steal copper, and then you cut right through a high voltage 15 kV or 150 kV, and bam, you're done. You have no chance. So, but those are unqualified people. Plus thieves, they're also unqualified. You guys are qualified. They're qualified thieves, probably. Gloves. The gloves that you're looking at, the gloves rating, the gloves that's smarter than Chad decided to rate it by a bunch of zeros and ones. Does that have 2 octs, 1 oct, right? Remember that oct? Everybody knows the Y oct. So the 2 octs, the 2 zeros, this one happens to be, and it tells you here, if you have 0, 0 and it up to, look at the DC and the AC. Everybody can see it's higher than the DC. So you can use a 750 DC on this baby, or 500 AC, meaning you cover almost all the systems that we use in the US with this big piece. So this happens to have, you guys feel free to look at these, this is class 00. And this one happens to say, this is class 0. So if it's class 0, what is it rated for? Up to 1000 volt AC or 1500 DC. 1500 DC. Okay, so maximum use voltage 100 volts AC, RMS voltage. So these are rated based on voltages, and then most of you guys will be between these two, will cover 99% of what you do unless you go higher than 1000 volts. If you're using medium voltage. Any comments, any questions? They use natural rubber and synthetic blah, 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 do 2 different materials, type 1 and type 2, and it will tell you what type they're using on these. As far for use purposes, this is type 1 on it, and made in Malaysia. Malaysia. So this is type 1 will be natural rubber. I don't know what this type is, probably this is also type 1. Different colors, but different higher voltage. Any comments, guys, about these? So that's how they rate the gloves when you work on them. You can see the maximum voltage right in here. Maximum voltage is 1000 volt and class 0, right? Everybody can see that? Class 0 on this. Okay. The couple of things, so that's basically about the gloves. So an arc flash, and the gear that you can dress up and all this good stuff. Everybody knows that these have to be stored in a safe place, so you have to test it before every use, right? And there's a simple test that you blow through them or grab them like this, and you're supposed to give them the air test. And if you hear them leaking, if you do it the right way, if you hear them making noises, it is leaking. So this means that you can use it. So you have to do a couple of tests on these, store them in the right location. And these, if you have to have visual inspection on these, if you see any holes on it, someone's to throw it. So there are a couple of things, guys, you store them in a safe place, not in a place where you can drop that flyer right to the top of it and make holes in it. So there's a couple of rules about using them. Okay. These are 2 exercises, guys, I have for you. 1 capacitor, 1 inductor, and a couple of slides we're going to do in a second. Capacitors. If you dealt with capacitors, and I'm sure you guys do, in the power industry, not in the low voltage industry, in the power industry, we use capacitors mainly to correct power factors, mainly. So we typically, when we specify, if you have a 15 horsepower motor in a piece of equipment, we usually specify a bank of capacitor that goes with it, 50 to 30 or higher. Why? Because your power factor go lower, you get penalized by excel energy because you are an offender. We call them offender. Meaning you're forcing electrical utility to give you more current than you are paying for. Cold store will have a medium, you have capacitors, typically capacitors break the power factor bigger than this one. Now capacitors store energy, right? Charges as energy. When you de-energize the capacitor, when you disconnect the capacitor, it gives you a DC kick for the capacitors. Meaning after you de-energize it, they're still dangerous. A lot of them guys come up with a deal when you literally de-energize it, it will shunt a resistor, put a resistor right across it. So we'll burn all the stored energy in this capacitor right through the resistor, and instead of burning it right through my heart. So a lot of major ones have that one. So stored electrical energy in electrostatic field of capacitor used for power factor correction must be bleed down to 50 volt within 1 minute by design of power disconnection. Stored, if you can't do that one, then you have to put a capacitor, a resistor that burns the equipment right across it. Coil. The other thing, I don't know if we have it here. The other thing is the coil. Yeah, we'll talk about the inductor. So that's basically the safety and how to deal with capacitors. There is a large storage capacitor of dangerous. Really dangerous, especially high voltage. They can get, when you de-energize it, they can give you a kickback energy that can shut down our equipment. Energized and de-energized capacitors is a bad business. I had one of my mentors, literally, I mean, if you do high voltage, there's a resonance. There's a resonance, like when you do transmission, resonate. If you put a capacitor and an inductor, which there's tons of them in the transmission lines, you get yourself a resonant frequency. Now you're transmitting, it's like transmitting signals, AM or FM signals. When these resonate, my supervisor told me one time, we walked into a transformer and the utility and the transformer was literally jumping up and down. Because they have a capacitor in the switch yard, now these utility work, and multiple inductors, it match at one point, if they match the resonant frequency, they start pumping up and down. It damages the whole substation. So just because you add capacitors, every time you add a component to the power system, you create an issue. But they are necessary evil. We need them to correct the power factor, but be careful when you disconnect the capacitors. You have to de-energize the energy out of it. So that's your capacitor. We have, I have an example, one of these guys, examples in the wire. Have a capacitor, you will energize it, store energy, which is a voltage up. When it's a DC, this one, will all the way to the 12 volts. When you de-energize it, when you discharge it, don't charge it, 12 volt, then you discharge it across light, the light will go on and then all the way, because most all the energy has been dissipated through it. Inductors. Inductors, the one that we store energy as electromagnetic field. Do you guys have impedance grounded generators here? Impedance grounded generators. If you have medium voltage generators, you have an impedance grounded generator. They don't use them in low voltage generators. What they do is they take the Y, here's the Y, and they take the center of the Y and they put an impedance and then they tie it to the ground. It limits the ground fault to the three-phase pole system. It make it, see with the safety stuff with the design. It make it safe for the equipment to handle the short circuit. So that's where a coil becomes, if you're disconnecting that impedance to work on it for radius. Be very careful. It stores energy as electromagnetic energy, so it could kill at a higher voltage. So what do you need to do? Store the electrical energy in the electromagnetic field. Motors, motors is an example too. They have coils. They energize them. They still have some voltage inside them stored. So make sure you don't go touch the ends. Transformer, coils, anything that has a coil. If energized with DC, would produce an electromagnetic discharge or inductive kick. When discharge, inductive kick, that's what you have in your car, the starter. We have you put a voltage across a DC voltage in a coil and give you that spark. Of course, you have to put the voltage very high. We have an example here of an inductive kick. So long story short, these two equipments you have to be careful as you handle them. Just because you disconnect it, remember how to disconnect and start working on them de-energized, they still have energy. They're storing energy. So you have to dissipate this energy. Any comments, guys? Any questions about these two sources of energy? Now, these are electrical energy storage. There is thermal. Remember that talk about thermal energy and all this good stuff. If you have equipment, you have to pay attention to it. Incident energy. in 2011, this is where start from 2011. In 2011, the NEC code book, I don't know if you guys went, if you're an electrician, you went to training in 2011. This is changed in 2011, requires every switchboard panel, service panel, only for the service, to have a label, to be labeled by the available short circuit, not the interrupting. So now we have a 4,000 amp switch here, it should say 4,000, has been there for years. What the voltage is, has been there for years. What's the interrupting rating, 85,000 amp, has been there for years. Now we're going to add to this information the available short circuit. That could be, if it's rated for 85, the available should be less than that. Let's just say 72.35. So 72.35. How do we get this number? You're going to go, now this is where if we had a job for my fellow engineers, we're going to have an engineer do the calculation for you, right? This, all what I said, guys, is an industry engineering standard. This is nothing new. Not the building or all engineering buildings that you have has this information. Should, because the software we have been doing it for years. So this is now forcing it in every other panel in the code. Instead of just being engineered project, any project that you work on have to have this label. Now with the available fault current, you can do the incident energy. That has a big impact on your incident energy on your arc flash. I always emphasize this is not like, well, if you have residential, these guys 240, 120, they're just peanuts. They don't worry too much about it. Almost always. I showed you guys a couple of examples of this one. Here's arc flash. It starts with the boundary, 24. We have the calories, 3 calories at 18 inches. Always, they measure almost always at 18 inches. You're standing at 18 inches, pre-qualifier comes at you as a qualified person in the proper PPE. PPF, 1 layer 6, and it gives you the leather and all this good stuff. The limited, these are for contacts. So what the limited approach and so forth, and what the gloves that you're supposed to write for each one of these. I showed you an example of it. Any comments, any questions about this? So that's, if you don't want to go through the whole hassle of working on it, especially you can have it labeled through an engineered project, stick it to your equipment. Minimum person protective equipment. This gentleman is working, de-energizing a piece of equipment. Well, the piece of equipment should not be de-energized from a distance. The rule is you de-energize the equipment when you control system first. Then you disconnect it. So, so the equipment, but you don't know if it's de-energized yet, unless you disconnect it, it's not de-energized, right? If you de-energize it, doesn't mean it's officially it's not de-energized unless you disconnect it, right? Safety-wise anyway. So here's what you need. This is category 0, safety glasses, non-melting, untreated natural fiber clothes such as untreated cotton and all this good stuff, long sleeve shirt and pants. So that's what you need to do in this. But the cover is on, right? Nothing is exposed. That's your basically category 0. They're up to 2 calories protection. But do you see short sleeves here? Cut shirts? No, not when you're working on energized equipment. Okay, now you get into working live. This probably category 2. With look at the insulation and all this good stuff. They still have exposure here, but category 2, the shield is good enough with the glasses underneath it, and the what are we missing here? Unless this is rated for
Leather gloves.
leather gloves. They have the leather gloves, the other glove. Yeah, leather glove. You have to two gloves. Unless this is rated for both. Right? I don't know if they make them, I don't think they will. So you have to have another, because if you have an arc right now here, this will melt. This is protection purely from contact, not from an arc. Right? Am I, if we can see that? Yeah. Okay, so the second one that I'm going to go is electrical work, electrical safety. This one, guys, goes through how you work safely around electrical equipment. We said that rule is to go through lockout, tagout procedures proper lockout tagout procedures. You put the equipment in a safe working condition, and then you start your work. That's the rule. Now the exception is to work on it energized. If you want to work on it energized, then a couple of things have to happen. Before you work on a piece of equipment, you have to do two hazards. You have to have two hazard analysis done. One is shock hazard. That will provide the limited, prohibited approach, boundary, and limited and restricted and limited, so you know where your boundaries are for the tools, for yourself, and for the public. That's your hazard analysis. The second one is arc flash analysis. Now we have to have an arc flash analysis for working. Why do you need to have an arc flash analysis? Because you need to specify the gloves, if any, and the tools. We need insulated tools, as well as the gloves and the tools and the PPE, the proper PPE you need to put on yourself. So that's basically, in all these hazard analysis, we talked about these tables. We'll look at it. So that's basically what this summarizes the whole lockout tagout procedures. As I said, if you don't do a calculation, the assumption is 4 feet. You must clear, or 10 feet recommendation. Remember the 10 feet recommendation for arc flash. Okay, so that's a couple of these. Personal lockout tagout procedures. We talked the proper. I'm sure you guys lock this way, right? Is that what typically you have your lock, and then you also tag the lock as you go through to have information about who tagged it. But you can use you have two options. The option number one is to have this one with a lock. That's the proper option. Or you can have a tag only, right? Obviously, the safer procedure is to have a lock. Exactly what you're looking at. You have your lock, then you lock it, as well as the tag. Specify who's doing the tagging and locking. I'm sure you guys have lockout tagout procedures. You have to be storing them. This is where you can use a lockout box for if you have a complex lockout procedures, where you can put all your keys in there, and one safety coordinator can monitor the whole project. And when do you need this one? If you went through multiple shifts, or if it's multiple contractors, or if you have multiple sources of power coming to the equipment, and then that individual becomes responsible for all the lockouts. So you have to store them in the proper place, right? So people can have access to them. I don't know if you guys, I'm sure you have some of these other, how do you lock other types of energy? You have sources where you can lock gas line, or you can lock steam line and so forth. Typically, we don't do that, do we? Because we have to have somebody else. You guys do it too? Don't you coordinate with other disciplines on that? Okay, with coordination, you might be the discipline that do it. Otherwise, do it. Yeah, lock out all other sources of power. We always concern about locking the electrical, but there's also other sources of energy that could be as lethal to yourself. If you guys can't sleep tonight and you want to do some calculation, I'm sure you guys will do it. This is how they do the calculation. There's at the end of the book, Annex D has a bunch of formulas. I'll show you if you have time. A bunch of formulas that you can use. First of all, you need, here's a transformer, 1500 kVA. That's primary 13A for 480 volt secondary. It's a low voltage in the secondary side. Here's the available short circuit, and here's the arcing fault. Look at the arcing fault as half the available fault. The arcing fault current, guys, is always less than the voltage fault. That's why voltage fault is, if you have a previous voltage, it's really good, because it's so high that the fuse will open so fast that the arc is not going to stay for long. But the problem is when you have a smaller amps, then the fuse is not going to open that fast. Okay. Here's the opening for this boy. It's set to open at 0.13 seconds to clear it. We're sitting at 18 inches. If you do the calculation based on the back, you can get 7 calories per centimeter. So that will be category 2. And we know what category 2 needs, a shield and a category 2 equipment. Hazard risk, what's here, category realistic for protection. So this is, and then this is another calculation. Look at the same thing, but it's the same information here, right? The voltage is still the same. The kVA of the transformer is the same. Actually, the voltage fault is lower. The arcing is also lower. Can you guys see that? The arcing is lower. What's higher? The time. This is eternity. You're allowing a second to sit on a 1 point. This is 60 cycle plus another, what is a quarter of 60? 15, that's 75 cycles. That's eternity when you should clear within 3 cycles. So if you allow this void to happen, look at the same distance, look at the category. Can I work on this Energized? No way.
Once.
Yeah. Yes. But remember what I showed you is what this piece of equipment that has no main disconnect. That's what the situation is. When you have a fuse, the fuse will open and interrupt the flow of energy. If you don't have a fuse or a circuit breaker ahead of the equipment, the only thing that will protect you is the high voltage in the transformer. You'll be dead before the primary of the transformer trips. So that's just an example to compare how the longer the arc stays, the worse the situation is. Couple of measurements here. Again, missing the arc flash. Another thing is verifying. That's a good example. Can you use this one to verify that there is no voltage? No. So it's good to use it just in conjunction with others. You're supposed to use, because these are they sense the magnetic field and they're not properly. You're supposed to go face to face, verifying them, face to ground, no voltage, and then test your meter before you do the measurement and after you do the measurement. So your meter is not faulted. Now we are guaranteed no voltage. And if it's high voltage, ground the phases too. Then we're good. So there's a lot of procedures. This is calculation from Annex D. If you guys go to Annex D in the back of the book, for a 50 kiloamp at 0.1 second available fault current, look at the inch from the arc and for a cubic box and open air. There's two calculations that they use. You remember that box? Cubic box is if you're looking at a pan. So the energy is channeled right at you. If open air is you're looking at a conductor up in the air, and it's nothing to channel the energy. Channel can go all over. Obviously, if the energy can go all over, it's safer, right? It's not going to be channeled against you. So look at this one at distance of 18. This is where they measure the calories. At 18 inches, if you are in an open air, you're looking at, what is it, like 0.8 calories. If you're looking at the cubic box, it pumps it up to, let's just say 20, 18, 17. So all of us guys are almost always, we are in the red, right? And look at that, how the further you go away, distance-wise, the less the calories will go. At inches from the inches, at 60 inches, that's 5 feet. At 5 feet, we're way, like, what is it, we're going to say 1? So say, at 5 feet. That's why, depending upon how big the shot, but look, this is the only example for 50 kiloamp. 50 kiloamp is not a whole lot. It's not unrealistic to walk into a 4,000 amp switch here, guys, and find a available short circuit close to 75,000 amp. And as a matter of fact, if you're parallel, like you guys do with Honda, it will exceed 100,000 amp if you do it while you are parallel. And that's a little trick that we did in a couple of projects is in order to make the equipment cheaper so people can afford it. If you will size the equipment based on 3 generators, 2 meg each running with the grid, that's the worst scenario. So you're doing parallel with the grid. And you run the short circuit analysis, you're guaranteed in a 4,000 amp, you will exceed the 85,000 amp. So you're going to get into 100. Now we get into a very expensive piece of equipment. So as an engineer and an owner, you have to sit and see, okay, is it worth it? Can I take the risk? While you're paralleling, if there is a short circuit, that equipment might explode. but only if you're parallel with the grid. But if you're not parallel with the grid, you will be below 85. And we did it in a couple of projects where you sign an agreement that says we are aware of this, and the owner said, okay, it's a risk that I can handle. So back into safety start with where? With design, but good design costs money. So that's where a lot of cutting corners sometimes. I trust that you guys are going to use this formula tonight and plug in DC is the arc flash boundary. That's how they measure it. 2.65 times MVAPF. This stands for what is voltage fault MV megavolt amp at the arc location. Megavolt amp. They don't say by kiloamp. There's kiloamp and megaamp. If you multiply the voltage to it, it becomes volt amp, right? So you take the short circuit, you short circuit in kiloamp and multiply it by 1,000 and then multiply it by the voltage. You put this number, multiplied by the T is the time, how long will it stay at that void, and square root of 3, that will give you the DC. DC is arc flash boundary. EMP is the maximum incident energy. This one, if you plug it into this big fat fluffy boundary circuit, dP is the distance from the arc, you have to put it here. TA is arc duration, how long the arc is going to sit there. And what is F2? F to the power 2 here. What is F? F is the voltage kiloamp, 16 to 50. If you plug all this information here, it should give you MP with the maximum incident energy. Long story short, if you don't rely on an engineer, go to the NXD and you can plug these in an Excel sheet and it does the calculation for it. But engineers do it better. I'm biased. So that's a couple of calculations that you can use. And oh yeah, these are the two gentlemen that invented this formula in '98. So the smart people work for IEEE and they come up with these formulas. And they keep modifying it, guys. Arc flash determination. You can do arc flash determination 3 ways. Arc flash. Number 1, you can use the table 150.7C15A and B. Remember that one that we were saying if you are installing a circuit breaker in this, under these circumstances, this is the calorie. Now the disadvantage of this, it looks at typical scenarios in the building. Now, if your scenario is not a typical scenario, that table doesn't do you any good. 15 kiloamp or was it 30 kiloamp interrupting rating, if you have higher than 30 kiloamp, that table does not apply to you anymore. So there's limitation on that one, but it's a good rule of thumb to use. You don't have anything. And if you're good with math, NXD can give you a couple of formulas you can plug in. And if you're like Chad Lazy, and you have a nice software that provided for you, you can use NXD. Also talk about IEEE 1584. This is a method that by multiple engineers sat together and say what we come up with based on multiple criteria. Then SPM, the company, Power Tools for Windows, their product, their engineers program, their software engineers, and now it's software. They add it actually to a software that they have. So you can buy the package. That's what I showed you. All the stuff is based on this IEEE 1584 standard. And don't be surprised if they come up with different answers. Any one of them should apply. So there's a lot of criteria. Which one is the most, IEEE standard is most stringent, so it will give you, you might go into category 2 where others take into category 1. So it's more stringent, I guess. Safer. Okay, so last thing, guys, is you get into a situation where I'm going to give you a break in a second, but I'm almost done here. Arc fault is a function of fault current and duration. So to limit the fault current, what do you need to do? I can't limit the fault current in the system. I can't, limit fault current is go shut down the compressor or the rooftop unit. Can't do that one. People will be mad at you, right? So what can you do to limit the fault current? The only thing you can do to limit the fault current is really put a current limiting fuse. That's the only way, visible way of doing it. You can't shut down loads. all the time to limit the fault current because that interrupts the people's process. We're in the business of making people happy in the buildings, not making them mad. So you put current limit fuses. I can limit the current. Now, by limiting the current, you limit the arc. Or I can put fast-acting fuses. You can only reduce the energy in two ways, either or both. You can reduce the current limit fuses, or reduce the time, fast-acting fuses. So these are the two ways you can do them. By limiting this, they will limit the arc flash. Fault current is always determined by the engineers. The software that I showed you, that I talked about, before you even do arc flash analysis, they build the one-line diagram of your system. Every single panel, you build it into the system, you push the line, and you do your ANSI or three-phase fault calculation system. It will tell you the available short circuit in every panel, typically down to 100 amp panels, 24120 or 48277. After that, then you go run another study called arc flash analysis. It takes that info from the fault current, the calculation you did, and apply certain rules of regulation for it. Basically, reduce the fault current down based on the duration, and it gives you a label. So it's really not rocket science for me, but I don't know how to program it though. I know how to use software. Thanks God for using it. Okay. I promise you I have 2 more slides. I'll give you a break right before we start the activity. Employers' requirement for safety program. Employers are required to have a safety program for you. And I have a list of all the safety programs. The safety program, guys, has highlighted a couple of items. Look at this one. First, identify and minimize hazard in the electrical system. So your employer part of the safety program is to identify the hazard. Any place that doesn't have a disconnect, insert a disconnect. If you have high fault current, then you can replace it with a fast-acting fuse, or you can replace it with a current limit fuse. You can do that. So that's where you identify the hazard. Have a work plan for the job. Who does what, when, and where. That's where the briefing before the job is. And have the whole plan, lockout, tagout. Place circuit in electrical safe condition, if possible. So the second thing is 2 options to work on any circuit. It's part of your electrical safety program. Work on it energized, then you go through the lockout tagout procedures and follow the symbol of the complex, or work on it energized, then you go through 2 calculations: arc flash analysis and shock analysis. And then it tells you the boundaries and all the stuff that we're doing, and then you give the equipment to the people, make sure they wear it, and you're good to go. And you do all the blocking and so forth. So that's where you put, they call it electrically safe condition before you work on it. Either energized or non-energized. You can de-energize it, or you barricade it and you put the PPE to work on it. Have a plan for unexpected results. What happens if somebody got electrocuted? What's your plan? So somebody has to be able to de-energize the equipment. If somebody got electrocuted, you have arc flash. Call the 911 people. Administer CPR, access worker skills and abilities regarding work needed. Assist worker skills and abilities regarding work needed. Your employer should be able to, can you handle a 4,000 amp switchgear or not? Your supervisor should know that. Part of your safety plan. Who am I going to send to work on the 38 switchgear? Based on your employer should be aware that X has training and medium voltage, but Y hasn't, so we'll send the X this time. So all this is part of your safe work program. Tools, have proper tools on the job, inspect them for safe operation. We talk about the tools. Regular inspection and have the safe tools. Isolate equipment to work safely. If you're not working energized, evaluate hot work for flash and arc potential. We talked about this one, guys. If you're working hot, PPE on site for the workers. You're supposed to provide your tools. Do you guys provide tools here, or you provide the tools for you? Typically, if you're an electrical contractor, you provide your tools, but these are one of the things that you don't provide. It's provided by your employer. The PPE here is your employer's responsibility. So that's, but your responsibility is to know how to use it and use it. So workers, site for the workers, train workers on the PPE usage and evaluation. That's what you guys are doing, some evaluation here and usage. I trust that you guys can put, put this one overall on, right? And put this one on. I'm sure a lot of you have done that. And then audit for compliance and update training. So you have to audit your system every time and for compliance and training. So that's part of your summary of your employer safety program. Here's the details. I added 3 slides, guys, but I thought this is really cool. This is this one coming directly from the annex here with detailed information what you need to do. I'm going to summarize it with a few things here, go all the way back. Look at the first thing is the principles. Typical electrical safety program, the principles: inspect, evaluate, maintain electrical equipment, land every job, de-energize, always if possible, right? Anticipate unexpected, identify and minimize the hazard, protect employees from shock and blast, use the right tools, assess people's ability, audit the principles, go over them all the time when they follow. So this is the principles. The control, every electrical conductor or circuit part is considered energized until proven otherwise. That's part of your disconnect and verify that the equipment are working. And you can go through all this stuff, guys. So that's your control system. And the last thing is the procedures. Purpose of the task. What are we doing? Qualification, number of employees working on it, hazardous nature and extent of the task, limits of approach, safe working practice, and PPEs, and a bunch of other things. So that's part of your electrical safety program to work on energized or equipment that has been put in a safe working condition. Any comments, any questions? So this, I just covered these as non-filtered for you because I thought it's really interesting, especially if you're working in electrical equipment, to have the full spiel detail. Any comments, any questions? So that's all we have for you guys. Let's take a 5-minute break, and then when we come back, we do have an exercise for you guys. The exercise is basically to take a couple measurements. I know if you're a German master, this is nothing compared to what you guys do, or even if you're a qualified person working, but I thought one exercise is about some couple of measurements, DC and AC you guys do. The other one is about inductive kick, the DC kick in a coil, and a capacitor discharge. And the third one is a sheet that you have to identify the proper PPE and gloves. So we will do 3 activities, and you guys will be fast. And then we'll have a quiz you and go over the quiz. Don't worry, you can work together on the quiz, and we can give you the answers. You submit the quiz to me, and then we do evaluation and sign the sheet, and we'll call it a day. How about that? 5 minutes? Thank you.
Thank you.
Yeah, I just made 2 batches here recently for my son as well. No, it's you know, I was remember one was blue flame, one was the red, one was the I put it over the white flags. 3 patterns. Oh, it's so hot. You can find cardboard on the bottom, I mean cardboard separators. I have a handful of reinforced handhold that is wow. Right. And I make it for 20
on?
and that thing will even you'll even do a 6-gallon kit with a couple of bottles like And that's because I know when I first started out, it was really, speaking of model here, model there, they're always different. You know, and a little bit more particular. Yeah, well, the thing is, so when we were doing batches, and you can have, this batch, and this batch. You know, yeah, but they have, I gotta keep them separate. And that's what I started doing. That gives my personal. I called them. Oh, yeah, all the time. We got big bids for them, but they want to be 67. He says, well, she just goes for this. And I went up in the back with most people somewhere else there. So, you know, went in the door and up to the steps. On the right, you know, these guys had like flying with them.
Okay. For the sake of the time, guys. You can do 5 minutes for that. Okay. For the sake of the time, if I just get your attention for a second here, we have, as I said, 3 activities that you can do. So if you do me a favor, grab the folder, and the activities should be in one side of the folder. So one activity should say activity number 1. Everybody grab activity number 1. Activity number 1, guys, is hazard and voltage. Activity number 1 looks like this one right in here. And I don't know how you guys were working here, so the Energized it. It has really simple for electricians, but it's meant to verify the voltage AC or DC and take some measurements. So we have two outlets, receptacles with a switch, and you're supposed to verify the operation of the switch and energize side lead circuit breaker. There's some measurement you need to take over here between different points and see what the voltage is, because we have a transformer, and is it DC or AC. So that's what you're going to do. This is activity number 1. Everybody see how it looks like this one. Now activity, so I need you work in teams of 2, please, so you can grab any activity. The other one, it looks like this one, guys. Everybody can see that? I don't know if you can see it here. It looks like this. This has it has a capacitor here. I can't show you that one. It has a capacitor. Maybe I should. There you go. There you go. I don't know if you can see it at the top. I can't point to it. The top one is a capacitor, and just charge and discharge with 12-volt system here, and just take some measurement. The second two is a coil with a DC kick on it, and you can see some spark coming out of it when you energize it and take some measurements. That's activity number 2. So we're supposed to take turns, guys, doing them. We have meters. The last thing that we'll be using, the voltage sensors. You know how to use that one. You put it next to the voltage, and it gives you some continuous light and noise, meaning you have a magnetic field. Not enough to verify that the circuit is energized. You have some meters. I don't use these meters. For me, I use Bluepress, and I'm sure or Ideal. But when you look at your meter here, the first thing you need to do is verify versus you're measuring AC or DC, right here, AC or DC. If you're measuring resistors, you have to put it on ohm. And the most important thing about when you use a meter, when you measure the impedance or the resistance of the system, you de-energize the system. Typically, we don't do that one except we're doing commissioning of the building, but if you're to measure the impedance, de-energize the system. Other than impedance, you can measure everything live, hot, current, and so forth. We have a meter that looks like this you guys have. You get you the amp. Measure the amp, lamp on amp meter, AC meter only. DC, they can make them, but we don't have. So I don't want to spend a lot of time training on this one because every meter is different, guys. So for the activity, all that you need to do is measure the current and measure the voltage in the current. You can see AC or DC. Pay attention to that one. So this is, we're going to go ahead and start. If you guys take teams, before you go though, I'm sorry. So this will be activity number 2, the one I showed there. The last activity, there's no module for this one. You can sit on around the table and work together. This is just picking the right PP for the job. So, and I know it's confusing here, but if you look at the first one, this activity, we have a scenario of 208 panel, work on electrical conductors, including voltage testing. You're working on electrical conductors. So what type of hazard is this one? The first thing you need to determine is the hazard category, insulating gloves needed or not, insulating tools needed or not, and the calories. For each 1, 2, 3, 4. Does it make sense, guys? For 1 through 4, you need to determine these A through B. 1 through 4, you need to determine A through B. Cool? And when you determine this in the back here, you guys were looking at that. You get this information from us. Okay. And then we have a quiz at the end. So why don't you guys take turns and go around? When you're done with one activity, you can switch the other. Cool? And we have less than half an hour to finish all this. Let's see if you can guys can pull it together. And please work with me. This one is this is actually. You guys have an activity to work on with one here. And there's one here, that's one here. You have 2 members. You guys have another one to work on? Yeah, okay.
Slowly drain down.
But then it says move the center toggle switch to the left position.
Drop it. We're down to 7.
Dropping faster. Okay, next size 2. 10 volts. Bring your spark plug gap. Well, come on. Yes, sir. And you release. Versus what when we get that. 10.6.
What about the heavy?
So we got 10 volts, right? Oh, one spark. You got one. You get a spark. How many volts was on that? We don't know. We're doing 10,000 volts. We don't know. Okay. There is no gap. Arc to the frame.
Well, in our
Arc to the what? No gap.
AC volts.
Because the other lead to the alligator clip. And two wires on
We're
it.
inducting, see the wires next to the other wire?
Yep. That's like push 3. So we're putting an induction on that? Through the wire. One. We actually have one. AC through into that wire.
This one.
Press and hold the black button.
Yeah, we done it.
In the air about a foot above the spark plug gap.
Is that different? Yeah.
It picks up the induction about a foot up.
There's one here and there's one there. There's one right behind you on the other side.
And I'd say detector picks up.
That one is.
Induction, right?
Saw magnetic field.
My copy of the geek.
Yeah. You guys have helmet?
Okay. Turn on. Unplug it. Cut the plug. Take a while to get that.
Yeah.
Yeah, why don't we do that?
The brake plan, 600 volts, and the next roll, voltage. 10,000 volts, is present with button number 3. Yeah, well, I missed that. I missed the one. Yeah, this one here. That's got a cool light. Yeah. Well,
You can see the voltage check and the capacitor and all stuff. Yeah. Now imagine a capacitor that's 500 kVA, kVAR, and if you work on high voltage, you said you want to keep
yeah, a couple of questions on what it was.
Yeah, we don't need to follow the Franklin.
The power plant guys do all the voltage stuff. I don't work on anything above 40.
Okay.
I've got the opportunity to work with them on a couple of cables. Yeah.
You go to the tool, it's 2 months.
Yeah, we did.
Then there's the third one.
Number 7.
But then why do they have more? So here's the circuit breaker and here's what covers us.
This is for with the remove or operation. So circuit breakers are fuse switch operation with the operation. Circuit breaker switch operation. Yeah, you can operate the switch with the cover on, not remove. Removable insert. Yeah. And you have to go to the side, actually, you have to go, if you look there, yes, this is just operation, just turn it on and on. The removal is right here. It says right here, remove, insert, they go by the language.
Okay, thanks.
How are we doing, guys? Good? Not too bad, huh?
I have a question for you. We're trying to do this one here. The one thing about this one here, you go to voltage, well, how much is the fan? You have AC, then you go fan. Well, that's what you screw this up on the meter. And I tried doing this. AC seems to be working for it. Yeah. So start writing down the number. 8 volt, this volt. That's it, you got a volt. Not all the time. The other thing is, I catch okay, 6.
Okay, I want you to do it for yourself. Where's the thing? I'll make sure that you get this here. So why don't you? This is the quiz.
Okay.
And sign in here. So it's going to be the first.
Okay.
They give you an now.
You got the quiz, I got a sign in sheet here. And of course, you get
I can sign this one right away and then get you off on okay, thank you. Okay, thanks so much. 600 volts with here, this thing. Only on one side. Okay. Thanks for very much. I'm going to go over this one, this one, and for this exercise, but I'm going to give you a quiz and do it. Okay. In a second. Okay. If you're done with both, I'm going to give you the quiz. For those of you guys who are done with all the stuff, I would like to take the values, you can look it out. There is a quiz that you can work with your function. So at least you can stay with it. The only thing I would like to do, you can do the quiz here, you can work with your partner, and I will go over this before you give it to me. I need the quiz. This is the quiz. Same thing. Here's the quiz. And here's the quiz. Is it down? When you go to the quiz, I need the quiz back. You're right to the end. And the other one is eval. I have 2 quiz and I have an eval for you, Chad. So you guys don't need to see over here, Rochester again. You can say Chad, send it back to I need to go to people like this. I'll go over the points here. Easy can use it with. This is right now. The next is you can work together to sign in your name and pass it. Just make sure you pass it on the other individual. If your name not on the list, write your name please and sign it. You can sign it. Everything else is Are you guys sitting here? I'll give you a quiz in it out. Oh, that's a lot of work. I'll let you get it for hands. Hold on. Well, I mean, it's this scale.
Where'd that come from? You gonna do that?
Well, we started and we had to go to the quiz.
Oh, sorry, and they give you a quiz and then okay. Yeah, I need this one for the quiz. And that's needed, I go over it. And I'll go over the quiz it down. You have a chance. You can work together on the quiz, I'll go over it. Okay, here you go. Respect your time, guys. I would like you to work on the quiz now, respect your time and mine, so you can get your here on time.
Boy, are you, which one? I don't know. No, that's right, Stone.
Here, I'm sorry, that's what you're doing.
You wanna just work on a tank?
Yeah, quiz and, yeah, please. So I'm gonna give you the quiz and the eval. So there you go, there's one quiz, and one eval. These are the rest are already for your own exercise.
Was it 50 AC and 100 AC?
Okay, guys, ready for the quiz? Review? Okay, so get you. All right. I want you to get your butts here. Okay, I hope the activities, guys, were okay. So we did the two activities that we had. One is just to get used to, I know you are, to use AC/DC measurement and answer a couple of basic questions. So that's kind of the activity number one. Activity number two, I hope you saw the discharge and charge, emphasize the gravity of release of energy, electrical energy or electromagnetic energy. So your answers, guys, as good as you can get. We're not gonna go over the activity. The quiz I need back. I need you nail it, guys, in the data. This is we keep for record for Mayo to prove that you guys have done the best training, safety training ever. Oops. Okay, let's go over the quiz if you don't mind me. Okay, what's the answer for number one? The NEC acquire all extra panels in automated willing occupancy to be marked with a flash. True or false? True. Number two, systems up to 100 volt DC are safe to work on without PPE. False. This is less than 50. 50. DC also? DC or DC? Yep.
Oh, yeah, same old.
50. Less than 50. Number three, so two is false. Number three, restricted upward strongly for a 480 panel is, you have to go to the table. It will give you it's 1 foot. That's from the, I know some of you guys might not be able to read the table. It's true. Number four, arc mass is measured in calories per centimeter as a measure of heat. It's true, but look at the centimeter though. The centimeter is squared. There's no square limit. I know this is kind of, this is what I mean. I know this is me. This is how they test you in the master. I'm not kidding you. Should it be false? Yeah, it should be false. I know. I don't agree with this because who's going to pay attention to the tool at the end of the set, especially centimeter? Who cares? Okay, yes, should be squared because it's energy over area. Number five, electrically insulated tools are rated in voltage and current. Just voltage. Just voltage, no current. They're not carrying current, they're touching voltage. So false, number five. Number six, determined flash risk categories is in 78 table 130.7C 15A. And B if you're doing DC. 130.7C 15A. 7C? C, yeah. As in chart. Number seven, guys, 70E lists two formulas for arc flash, and one of them is open air, the other way is cubic box. The cubic box. Lockout tagout all circuits unless it increases or adds hazard. Additional hazard involved or increases hazard. Number nine, electrical flash energy depends on the current involved and time. Time is everything. Current and time. Amount of current and the amount of time. Number 10, Just fuelable burn is considered to be, you guys remember that cutoff? 1.2, thank you. That's how they draw the boundary. Just fuelable. 1.2 calories per centimeter squared. Does use have centimeter squared in it? Eventually, it does. Okay. Number 11. This category 2 flash hazard requires PPE rated at 8. And you guys know where we got these. Cotton long sleeve shirt and blue jeans is sufficient for 0, category 0. The class of voltage insulated gloves needed for 480 live work is 00. 2 off. The highest risk category is considered to be 4, at least by the code. And measuring voltage, just measuring the voltage in a 480 FCC starter bucket, you need which category? Did you guys get there? Number 2. Number 2, just measure. Okay, do me a favor, write your name on that. Please do the evaluation. And I would like to thank you guys for attending my class. And we will see you in the future. Good luck. Thank you. I would like guys the 2 forms, and there is a piece before you guys go. And your names are on a piece of paper being circulated. Make sure you sign in on that piece of paper and give me the evaluation request, and the rest is yours. Thank you, sir. Thank you.
Reminder, what are you doing now? Taking all my stuff?
Make sure you guys all sign in. Thank you. Good night.
Want these too?
Drive safe.
That's all I hear.
And work on the Energized equipment.
Work on it, yeah.
Work on it.
Work on it.
Work.
Thank you, guys. Okay, thank you. We'll see you. Thanks. Okay, let me see how we have here.